Yes. Good evening, good evening, everybody. I have been standing here since 10 minutes and I have been reading your comments. But yes, because of some technical fault beta, I mean, no, not fault delay. So, yes, we are back. I mean, I am back. So, good evening. Good evening, Muskan. Good evening, Hasani. Good evening, Priti. Good evening, Devrajan. Rabbit. Ananya, Hasani, superstar. Neha is here also. Neha was there in my J channel also a day before, and has done those colligative properties, mains and advanced question like anything. So, superstar, Neha, God bless, beta. Casper, then we have Janvi, Gaming, BWO, Gaming Bow. Then we have Anurag, Faizan, everybody. Good evening, beta. Good evening, very good evening. Now, what is the task for today? Beta, 21st June, not even 9 days from today. So, what is the plan for today? Chemistry organic revisions. Yes, Anupam, good evening. Chemistry organic revision. Now, what does chemistry organic revision mean? Beta, 17 to 18 questions directly you can attempt in the single go. As I have already discussed in my previous lives, beta, please make sure you are going to attempt your NEET examination as two papers. Paper 1 will be finished. Paper 1 must be finished in the initial 1 hour 30 minutes, maximum 1 hour 35, maximum 1 hour 40 minutes. Do all the doable questions and do not try to attempt physical chemistry more. Do not try to attempt physics, those area of physics where you have to do calculations. If you feel you have to write 3 lines, don't attempt it, because in physics also you will be having modern physics questions. In chemistry you will be having organic and inorganic, and because we have obviously done those sessions of inorganic, so today's job is to revise all the chemical reactions, all the chemical equations. From where? Sir, from organic chemistry. Why? Because they can be done in the first half of your paper, but in order to attempt them in the first go, beta, you have to make sure that you revise all the content very properly. Now, I have received many of the requests also that, sir, you are teaching all the content using questions, but sir, we do not. Some of you, obviously the large chunk of you, because out of the 24-25 lakh students who will be appearing for NEET, uh, I guess 1 lakh students are actually here. They actually, at this point of time, they are only here for attempting questions. But beta, what about the remaining 23-24 lakh students who are still not comfortable with the theory? Even if you are comfortable with your theory, beta, let us revise the complete organic reactions. So GOC, IUPAC, that general organic chemistry, I have separately taken in my previous live. Now again, I'm requesting each and every one of you, whoever is serious enough, that although sir I'm not prepared, but I want to maximize my marks. So how can you maximize your mark? Beta, please go to the live section of PW NEET English channel, and whatever lives I have personally done for chemistry, make sure you watch all of them. And along with this, if you are not confident with the organic reactions, then today is your session. But yes, it is going to be a long session. It is going to be a long session because we are going to theoretically deal with the conceptual side of organic reactions. So sit back, relax, and start studying. Don't try to make copy all these notes. Don't try to write all these notes. Just try to iterate all the reactions with me. The more you sing a song, the more that song comes to your subconscious. So try to iterate the reactions with me, and that ways you will be able to learn them right now. Sir, but I will be needing these lecture notes. How can I take these lecture notes? These lecture notes will be directly flowing to your desktop or maybe mobile. Just go to PW NEET English WhatsApp channel. The moment I will be finishing this live, you can download all these notes from the WhatsApp channel. I hope I have made myself clear. So Gaurav hu yaar, hello. Ravi, hello. Divya, Abhishri, Everybody, now let us start the process, beta. Now I do not have the polling option for this particular session. Why? Because beta, definitely I want this class for you so that you can revise your organic reactions, because I will be starting with hydrocarbons. So make sure you iterate all these reactions with me, alkanes starting with alkanes. Now sir, acha, in order to be time efficient, beta, because obviously I know the you have to fight a race against time. So I have personally written these notes, so these are my handwritten notes, so don't worry. I have written these notes for you, so that if I will be writing them right now, then I could not have given you much of the content. So please make sure you download these notes from PW NEET English WhatsApp channel as soon as the class is done, and try to learn them with me right here, right now. Don't wait for sir, I will revise it today. You do not need that revision. That revision can also be done right now while you are watching me live. But yes, make sure do not leave the session in between. Please finish the session with me till the end. Yes, it will be an extended session, but beta, it is going to be rather very fruitful for you. Chalo. So Chalo, perfect. So I hope everybody is ready with whatever you want to write in a pen and copy, just the brief. Like for example, what are we starting with? Sir, we are starting with preparation of alkanes. Acha, how do we, what is the way we approach organic chemistry, beta? For all the chapters of organic chemistry, the first thing we should remember is the preparation. The first thing that we should remember is the preparation. Let me just duplicate this for me. The first thing that we should remember is the preparation. Second thing is the chemical reactions, because most of the time question comes from this packet only. So first thing is preparation. What are the preparation of that particular compound? And second is the chemical reactions. The more we start going from hydrocarbons to alkyl halide to alcohol phenol ether to aldehyde ketone carboxylic acid, the more compact these reactions will become for us. So please make sure that you are giving full focus in the class, and do not get up from your seat, and start iterating this for me with me. Now, what is the first thing that we are trying to, what is the first organic compound for which first we'll be reading preparation, and then we'll be reading the chemical reactions? Sir, just point blank the reactions? No, beta. I will be discussing the relevant mechanisms also. Why? Because beta, now your NEET examination is at par with JEE mains. So you should definitely know some reaction, not all, but yes, wherever it is very important, I'll be giving extra information also regarding that reaction. Okay, chalo, perfect. Now, we are starting with preparation of alkanes. So our first organic compound is alkanes. First we'll be doing the preparation, then chemical reactions. So what is the first preparation of alkane? Sir, from alkyl halides. Now what is alkyl halide, sir? Alkyl halide is Rx. If I remove that X, I will get an H. That means it will become an alkane. So the first step of doing it is using a reducing agent, because what's a reducing agent? Sir, reducing agent directly adds hydrogen. Okay, sir. That means if I have my alkyl halide, then I just need to learn these reducing agent which will directly remove this X and add this hydrogen, thereby producing an alkane for me. Now, what is the list of these reducing agents? Now, the list of these reducing agents are, the first one which I have done with a pink color is zinc in acidic medium, because that is the only reducing agent that is actually given in NCERT. So first is speak out with me. Preparation of alkanes, first is by reduction of alkyl halide. Reduction of alkyl halide, first thing is by using a reducing agent. What is that reducing agent? Zinc in acidic medium. Now, some extra. What extra reducing agent you need to know? Sir, zinc Slash H plus means I have a dilute acid. Sir, even a weak acid like carboxylic acids can also be used to create that acidic medium. Yes. So sometimes the question can trick you by writing acetic acid. Sir, even if you write HCl, if you are taking dilute HCl, then the number of H plus ion is limited only. So even weak acid can do that. Because zinc is an amphoteric metal, therefore, because zinc is an amphoteric metal, so it can give this reduction, these nascent hydrogens with an acid also, with a base also. So with NaOH, it can also act as a reducing agent, and this becomes a very famous reducing agent, which is zinc copper couple in ethanol. So these are the other reducing agents, but yes, this is the famous one. This is the one which NCERT mentions, which is zinc in acidic medium. Moving forward, do you need to know some extra reducing agents also? Yes, beta, because they will be helping you in the other organic reaction details. So let us summarize all of them together. So what are the list of other reducing agent? Sir, there is the famous reducing agent, quite expensive, which is lithium aluminium hydride. Now this lithium aluminium hydride gives H minus hydride ion, and therefore I do not want that hydride ion to react with any polar solvent, so I take this LiLH4 in an organic solvent, which is generally an ether. So, sir, can it reduce 1 degree? Yes, it can definitely reduce alkyl halide, but it is specific. With 1 degree, you form your alkane. With 2 degree, you form your alkane. Sir, but with 3 degree, it acts as a eliminating agent. You can definitely see it is removing HX and producing the corresponding alkene. Now, this is an important point which many of the students miss, and which generally teachers do not give in examination, and therefore NTA can find very much interest in this. So LiLH4 is a perfect reducing agent. It can also reduce alkyl halide to form alkane, but only 1 degree and 2 degree. With 3 degree alkyl halide, it rather does beta elimination. And what does beta elimination produce? Beta elimination produces an alkene, because sir, lithium aluminum hydride will give H minus. H minus can act as a base also, and in presence of a base, if I can form a substituted alkene, then that gives me a Sidzef product. So a beautiful creation of Sidzef product can be understood with this. Moving forward, now, what is next, sir? Now, sir, do we have to learn some other reducing agents also? Yes. The next famous one is red phosphorus in HI. Even this red phosphorus in HI is used in biomolecules in order to reduce glucose and form that 6 carbon hexane, that alkane. This red phosphorus in HI heated, technically the temperature is somewhere around 150 degrees Celsius, but do not be concerned about the temperature can vary, so depending upon what the reactant is. So what we should learn is, at elevated temperature, red phosphorus and HI also acts as a reducing agent. Next is, sir, the famous formation of Grignard reagent. Now let us do this reaction. Let us at least write few reactions. Let us do this reaction. Sir, if I have a alkyl halide and I try to react that alkyl halide with magnesium, so then definitely what I will have, beta, definitely you will have a formation of Grignard reagent, R, Mg and X. Sir, why you have written like this? Because Grignard reagent is a compound which has both covalent nature also and ionic nature also. So here it is having 50% covalent nature, here it is having 50% ionic nature. So once you subject this compound with hydrolysis, sir, magnesium is a highly electropositive species. So this bond will be broken. It will be getting the OH minus ions from water, and this poor guy will be getting H plus. That means, again, sir, you can produce RH. That means, sir, this magnesium in ether followed by hydrolysis can also reduce alkyl halide to produce corresponding alkane. Sir, what else? Now, what is the mechanism actually? So you do not have to know that for doing basic questions, but yes, beta, for good questions you should know at least this much, because JEE mains has also started doing the statement based questions. So they ask in the statements the theory regarding the reaction that is happening. So a bit of mechanism you should know. So sir, the mechanism is also not very difficult. Why, beta? Because sir, we know zinc is a metal. Metal has a tendency to release electron. Once the electron is released, sir, this alkyl halide having this halogen which is highly electronegative will try to gain that electron, and sir, radicals are produced. So in presence of high temperature, sir, in presence of sunlight and in presence of metal, homolytic fission take place. That means, sir, this bond is broken. Okay, not like this. First this electron will take this electron, and because it has taken this electron, so R minus is formed. Yes, here some references even say this is homolytic fission, but yes, most of the references say that during this process formation of carbanion take place. Again, I'm repeating this. Why? Because technically homolytic fission takes place at elevated temperature, one, sunlight too, and in presence of metal. Here metal is present with an acid, so because acid has polarity, therefore the possibility of plus minus formation is preferred. Although there are some reference, in fact Morrison and Boyd, the previous edition, yes, the edition which has came with friendship with SM sir, because you have another updated Morrison and Boyd for you. But yes, in my time, those references have written that this is a homolytic fission. But yes, let us keep it simple. So because sir H plus, so polarity is good. So because polarity, I can have plus minus generation. So this becomes an heterolytic fission, and because of presence of H plus, this R minus will be attached, and you get your alkane. I hope everybody is clear. Sir, is there lone pair on R in Grignard reagent? No, beta. In Grignard reagent, there is no lone pair. But here, once X has taken the electron, you have got acha. Okay. This is X minus beta. No, I beg your pardon, because I have made these notes so that I may not take much of time in explaining these notes. But yes, I beg your pardon. This should be R plus. Now, acha. Nahi. Why I beg your pardon? Actually, beta, let me do this mechanism properly for you. Ultimately, this X and this R both are dissociating heterolytically, producing R radical and X radical. But because zinc is giving two electrons, so one of the electron is going here, another electron is going here. That ways this is also X minus. That ways this is also R minus. So yes, definitely you have lone pair of electron in this case. This is not the mechanism of Grignard reagent, beta. This is the mechanism of reduction of alkyl halide using zinc in acidic medium. So a better one, because here first I am initiating homolysis only. First I'm initiating heterolysis only with an idea that there is presence of metal. So once metal is present, what preferably fission you will do? Sir, we will do homolytic fission. That is what has happened initially. But yes, homolytic fission technically has created their free radicals. So here you have your free radicals. So that is good, sir. But after formation of these free radicals, because there is excess of electron, because 1 mole of zinc has given excess of electron, 2 electrons. So both of them can be accommodated because both are electron deficient. Obviously, the chemical kinetics, the reactivity with which X minus will be gaining that electron will be more. But technically you can't stop this also, because ultimately this is also electron deficient and metal will supply excess of electron. So technically this R can also form an carbanion, but yes, the reactivity with which, the rate with which this R minus will be forming will be less. The rate with which X will be converting to X minus will be more. I hope a very good mechanism, but I hope everybody is with me now. Ultimately, what we have discussed, the first preparation of alkanes is through alkyl halide using zinc in acidic medium. I hope everybody is with me on this. Moving to the next one. Sir, again from alkyl halide, can you do another method? Yes, that's why I've written second. So you can use alkyl halide and form alkane with another method, rather a very famous one, which is Wood's reaction. Now let us do some exploration regarding Wood's reaction. First thing is very simple. What? Alkyl halide with metal in presence of dry ether will form RR. Again, mechanism is same. This radical will be formed, another radical will be formed. So radical will have chain termination, and chain termination will form an alkane, but alkane with double double carbon atom. Sir, odd plus odd is also even plus even is also even, and hence with Wood's reaction you can have alkanes having even number of carbon atom. That is what I have written also, that symmetrical higher alkanes are formed with even number of carbon atom. Therefore, methane and all the alkanes which are having odd number of carbon cannot be easily prepared. Sir, why you are saying easily? Because you can use a mixture of alkyl halide. So mixture of alkyl halide can give you alkanes with even number of with odd number of carbon atoms, but over there you can have n number of other products formation also. That is a limitation of Wood's reaction. So let us give a basic example first. So if I have tertiary butyl chloride, so tertiary group is a 3-degree carbon. This 3-degree carbon is constituted by how many carbons? Sir, total 4 carbon. So at over here I replace a chlorine. Sir, sodium will take away this chlorine and a radical will be formed. This radical. So this radical and another radical will do chain termination. So let me draw that for you. This is the first unit, sir. This is the second unit, sir. So this is a symmetrical alkane. Now what is its name? Let us quickly revise IUPAC also with this. 1, 2, 3, 4. So this is 2, 2, 3, 3 tetramethyl butane. I hope everybody is clear with me. Now moving to the next one. Sir, what is the limitation of this Wood's reaction, sir? So let us do. Sir, how many degree carbon atom is formed as Wood reaction? Beta, degree of carbon, Gaurav, degree of carbon will depend, like for example over here. What is the degree of carbon? Sir, because carbon and carbon are attaching, so obviously degree will increase, but only on that side which is doing the dimerization. Else whatever degree you have will remain the same. Now, sir, what are the limitations? Sir, what are the limitations? So let us do the limitations also. Sir, the basic limitation which I've already discussed, that if you take mixture of alkyl halide, sir, here I have methyl bromide, here I have ethyl bromide. Sir, methyl bromide, ethyl bromide, because you have taken two different components, so obviously the probability of they forming the radical is more. So what product will be formed in more percentage? Sir, cross product. So I'm not denying to the fact that this CH3 and this ethyl group will meet and form a propane. But why I'm saying it is a limitation? Because beta, this will not be the only product. The percentage yield will be very less. Because the percentage yield will be very less. Why, sir, it will be very less? Because there are probability of other product formation also. How, sir? Now, beta, you can have dimerization also. You can't stop one methyl to terminate the chain with another methyl, so you can have formation of ethane also. You can't stop ethyl radical to dimerize with ethyl. That means, so you can't stop the formation of butane also. Next, what is this? Disproportionation. So disproportionation can also take place, but yes, for disproportionation you need more membered carbon. For example, if you have ethyl radical, let us see this ethyl radical. This ethyl radical is this, sir, because you already have metal. Sir, metal if present, then homolysis can take place further also. Where, sir, this C bond H can also undergo homolysis. Yes, sir. So I will get a H radical, and this carbon both have got that radical, so they will have chain termination within the molecule, sir. This will result in the formation of alkene. Sir, but how it is disproportionation? Beta, ultimately from this compound what you are doing? Sir, I am removing hydrogen. Removal of hydrogen is called oxidation. If this hydrogen is added to another ethyl radical, then this compound will be ethane, and it has formed by addition of hydrogen. Sir, addition of hydrogen is called beta, addition of hydrogen is called reduction. So if in a reaction the same compound is getting oxidized also, is getting reduced also, then such a reaction is called disproportionation reaction. So a very famous question for your NEET examination. During Wood's reaction, disproportionation may also take place. I'm not saying this will be the major product, but yes, because of the possibility of these n number of products, percentage yield of this will be less. Hence, Wood's reaction is not a good method for preparation of unsymmetrical alkanes or alkanes with odd number of carbon atoms. I hope everybody is with me on this. Perfect. Now, next, sir, because we are studying reaction with metal, so let us give us more reactions. Now, as you know, homolytic fission do not even care whether your bond is stable or not stable. Why I'm saying this? Because these aryl halides, because of the lone pair of oxygen, they are delocalized in the ring. This bond has partial double bond character. So all the reactions of alkyl halide are not given by aryl halide. But what reactions? Sir, heterolytic fission. So homolytic fission do not even care. Because why they do not care? Because they already take place at extreme condition. So at extreme condition, I do not even bother whether this bond order is 1 or having some more partial double bond character. This bond will definitely break. Why? Because sodium, being a reactive metal, will furnish electron. Once the electron is furnished, chlorine, being electronegative, will take that electron and a radical will be introduced here. And radical termination can here also create aromatic compound, which will be biphenyl, a very important reaction for producing these aromatic compounds. Now, sir, add them, sir, because Fittig said sodium can do free radical formation of aryl halide. Sir, Woods said this for alkyl halide. So if you mix both of them, then you get a alkyl benzene. So this alkyl benzene is also termed as a naming reaction, and this is termed as Woods-Fittig reaction. I hope each and every one of you is iterating these reactions, beta. If you iterate this inside your room, shout out these reactions, they will definitely get into your ears, and beta, the retaining capacity will increase. Even you do not remember these reactions, this is the way by which I will be doing the complete organic reactions today in this live. Yes, I know that will definitely be taking a lot of breath out of me, but beta, I have done this. I could easily write these reactions and come, and that would just have allowed me to finish one chapter or maximum 2 chapters. But that's why I have written them back, so that I can give you more content, because beta, 21st is very near. I hope everybody is with me. Moving to two more reactions of metals, sir, because you are discussing about metals, so discussing everything, no matter it belongs to alkyl halide or whatever, because you have to summarize everything inside your brain. So sir, can this thing happen with another metal also? Yes, if you use precisely the aryl iodide. Why, sir? Because beta, the bond length is quite large. Technically, it happens with bromide also. Yes, obviously not with chloride and fluorides, because over there the bond length is quite small. And sir, sodium is a very reactive metal. Copper is a D block metal, sir, not that reactive like sodium. So I need a greater bond length, which is offered by iodobenzene. So this iodobenzene reacts with copper and do the same thing, formation of biphenyl. But this reaction is termed as Ullmann reaction. How to remember this? Copper is Cu, Ullmann is U. So copper Cu, Ullmann U. With the rhyme of UU, you can remember with copper it is called as Ullmann reaction. And when zinc is used, again to form, yes, it is with zinc, because we know zinc is not even a transition metal. Why? Because it has no MTD. But yes, since it is also a metal, not very reactive, but still this can also be used, because ultimately giving 2 electrons is very much possible for zinc also. So with zinc, the same Woods reaction can take place, but this was introduced to the people of science by Frank Land, and hence this is known as Frank Land reaction. This finishes the first preparation. of alkanes from what? From alkyl halide. So sir, this will be acting as a reactions of alkyl halide also. Yes. So this is how your organic chemistry gets shorten. Why? Because with one preparation, sir, for other it can act as reactions. So with this, we have also covered alkyl halide, and I hope you remember. Let us quickly summarize. First, sir, RX with reducing agent, precisely zinc and acid, forms RH. Second, sir, with sodium in dry ether, RR is formed. But sir, you don't use mixture of alkyl halide or percentage product will decrease. If somebody is grabbing your throat and asking what is the major product, then obviously the cross product becomes the major product. I hope everybody is clear. The rest of the detail you may or you may not retain with yourself. If you are iterating them with me, then obviously they are going in your head once. You can obviously try to revise them with the lecture notes. PW NEET English WhatsApp channel. Moving to the second method, from unsaturated hydrocarbon. This we know from class 9-10, sir. Sir, alkene or alkyne undergoes catalytic hydrogenation. So what is this catalytic hydrogenation? Hydrogen in presence of nickel, platinum and palladium. With platinum and palladium, you can even do this reaction at lower temperature. Why? Because platinum and palladium has great sense of adsorption. So because they are highly specific catalyst, highly reactive catalyst, therefore even at low temperature you can perform this reaction. But yes, with nickel you need elevated temperature. With platinum and palladium, even room temperature can turn your unsaturated hydrocarbons to corresponding alkane. Moving forward, sir, do we have some other catalytic reagents? Yes. Sometimes instead of nickel, RE-nickel is written. RE-nickel is nothing, but when you increases the catalytic action of nickel, so that becomes your RE-nickel. And yes, one extra detail is whenever hydrogen is added, it is added from the same side. So hydrogenation is a syn addition. What is syn addition? When the adding species are added from the same side. So do we have another addition mechanism also? Yes. Sometimes you are added in the opposite fashion. So this becomes the stereo selectivity and stereo specific nature of a reaction. But at least you should note only this much, that because hydrogens are very small, so they can be added from the same side. So this is a syn addition. I hope everybody is with me on this. Chalo. Is this video is enough for learning? Yes. Shri Ram studies. It is beta. But yes, you have to be with me. Shri Ram, you have to be with me. You have to iterate these reactions continuously with me. And if you do that, definitely beta, it is going to help you like anything. Chalo, perfect. Moving forward. Great. Perfect. Now, sir, next beta again. For carboxylic acids also, for alkanes also. So next preparation of alkanes is from carboxylic acid. First method is soda lime decarboxylation. As the name suggests, I need soda, which is NaOH. I need lime, which is calcium oxide. Industrially speaking, it has to be taken in the ratio 3:1 because the active reactant is soda, which is NaOH. Lime is just used to keep the reaction mixture dry. Why keeping reaction mixture dry is important? Because beta, otherwise NaOH being a polar compound, being a ionic being a strong base, it will go and dissolve in water, and rather it will not participate with this organic compound. But I want decarboxylation. What is decarboxylation? I want the CO2 to be removed. The CO2 is removed in the form of Na2CO3, and this R and this H is added to form an alkane. Make sure whatever will be the number of main chain carbon atom in your corresponding carboxylic acid, the alkane formed will be having one carbon less, because one carbon is released in the form of CO2. CO2 is hygroscopic in nature, and it absorbs moisture also, because with moisture also NaOH will not allow this reaction to take place. Therefore, because of the hygroscopic nature of lime, it is used in the percentage of 25%. Whatever soda you use, at least 25% of that you should use your lime. Now, sir, one thing, sir. Why? For good questions, sir. Sir, basic mechanism, sir. Okay. Beta, this is your carbon ion. Now, if a question is coming that you have 3-4 different compounds and it is asking who will undergo decarboxylation easily, then this mechanism will help you. How, sir? Beta, this is your carbon ion. Ultimately, as this oxygen will give the lone pair, so this carbon will receive the extra electron. So a carb anion is formed. And you tell me who increases the stability of carbon ion? Sir, electron withdrawing group. Who decreases the stability of carbon ion? Sir, electron donating group. So let's say if I ask you, that I have two different carboxylic acids. Let's say this is C double bond O, ONA, sodium salt, and here I have used a carbon which is having one more methyl group, but rather here I have used a carbon which is having, let's say, this CH2 is connected with a NO2 group. That means that if minus is here, then this NO2 will try to, although inductive will not be happening till that long, but as compared to the first one, this will undergo decarboxylation with greater kinetics. The rate of reaction with decarboxylation happening here would be more. So for such conceptual question, you should know mechanism also. So CO2 is gone, and once CO2 is gone, it is mixed with NaOH, because in CO2 oxidation state of carbon is +4. Sir, acidic oxide base will form salt, which is sodium carbonate, and this R minus will receive H plus from the solvent, and you get your corresponding alkane. I hope it is also clear to everybody. Yes, perfect. Perfect, Muskan. Perfect, everybody. Now, moving forward, sir. Sir, first method is soda lime decarboxylation to produce alkane. Sir, alkane produced with one carbon less. Sir, second method, second method is coal-based electrolytic process or coal-based electrolytic method. What it is, sir, you again use sodium salt of carboxylic acid used. Yes, you can use sodium salt also, potassium salt also. Bring this into water and pass electricity. Once you pass electricity, you get alkane and CO2 at anode. You get hydrogen and base formation at cathode. That at anode, this at cathode. Remember one thing, here also CO2 is removed in form of carbon dioxide is removed in form of CO2. This R radical will now give chain termination with another R radical. So soda lime decarboxylation will form alkane with one carbon less. They will form an alkane with one carbon less, then dimerize it. So it is actually forming a higher alkane. I hope everybody is clear. Next, sir, basic mechanism for this also, rather, because this is important, this is even given in NCERT. This mechanism is even given in NCERT because it also help you to learn the concept of Faraday, the law of electrolysis, which is there in electrochemistry. So let us do this very quickly. Sir, I have added a battery. So positive terminal connected, so this is plus, negative, so this is minus. Sir, at plus, what ion will move? Sir, negative ion. At minus, sir, positive will move. Sir, minus will do what? Sir, minus will give electron. Giving nature is oxidation. The electrode at which oxidation take place is known as anode. That's why in electrolytic cell, anode is the positive terminal, not otherwise. On anode is a terminal at which oxidation take place. So here oxidation is happening. Who is getting oxidized? So this electron is giving electron. Electron gone, sir. Radical came. Once oxygen has this radical, it will snatch electron of this carbon. The homolysis will take place over there, and you have received your alkyl radical. Alkyl radical does the chain termination and forms your higher alkane. Happening at anode. So what gas is released at anode? CO2. Alkane is also produced at anode. What about cathode, sir? Sir, reduction, that means gain of electron. Again, competitive electron transfer. Na plus can also gain electron. Water can also gain electrons. Sir, come on, we do not even have to read that electrochemical series. We know sodium is a metal. It wants to give electron. So why the hell the sodium will want to take electron? And obviously its reduction potential is very less. Reduction potential of water is quite high. So who will take electron in water? Sir, hydrogen is in +1 oxidation state. It will take electron, form hydrogen gas. Sir, from water, hydrogen is gone, so what is left? OH minus. That OH minus and Na plus will make the medium basic. At what electrode? Sir, at cathode. I hope everybody is clear. Chalo. Next, sir, can we use this mechanism to understand a good question? Yes, you can also not alkane. You can also form an alkene, sir. In Wood's reaction also we have done that, but over there that was the minor product. But here, if you have succinic acid, what is succinic acid, sir? 4 carbon carboxylic acid with terminal carbons having COH. Sir, with sodium metal, they will form sodium salt because carboxylic acid is a stronger acid than water. Sir, once this is formed, if you do electrolysis, sir, CO2 will be removed and this radical and this radical will come here. Sir, if I have radicals at the vicinal position, why the hell I will want to do the chain termination outside? I will do in-house chain termination and I will definitely can form alkene. Yes, sir. If this guy can meet with another guy, then sir, cyclic compound can also form. But beta, we know Beer strain. This carbon is supposed to be tetrahedral. So this angle needs to be 109 degree 28 minute, and because of the formation of cycle, sir, it will be less than. So it will be a strained structure known as Beer strain. So this will definitely be your minor product. Rather, alkene will become your major product. I hope everybody is clear. Chalo, perfect Hasini. Chalo, great beta, great. I'm very happy that there are many serious students who are actually learning this. Because yes, I was having an idea that rather I should do just questions. Why investing so much of energy? But yes, I thought that if I'm able to help even few, then this is work done for me. I will sleep. I will have a good sleep, even if it is taking a lot of efforts. But still, if I'm able to help at least even one, and I guess I have more than one students over here. Chalo beta, perfect, perfect, perfect Muskan, perfect Saharika, perfect Shivaraj, perfect guys, perfect Anurag. I'm deliberately seeing this beta because your message gives me energy. So Rabbit, perfect yaar. Wiz, Neeta, chalo, great. Now, sir, again, sir, more preparation of alkanes. Yes. Although this is not there in NCERT in chapter of hydrocarbons, but sir, you are summarizing things for us. Yes, I am. So again, sir, can you give more preparation of alkanes? Yes, beta. It can also be formed from reduction of carbonyl compounds. How, sir? You do complete reduction. Sir, carbonyl compounds are either aldehyde or ketone, aliphatic, aromatic. I do not even care why, because I am interested in this carbonyl group. If I add hydrogen here also water will be removed, and sir, I will be getting an alkane. What are the reagents who has the capacity to do such strong reduction? Two. And therefore naming reagents: Clemenson reduction, which is zinc alloy with mercury, known as zinc amalgam in acidic medium, and then Wolff-Kishner reduction, which follows stepwise reaction. The first reaction takes place with hydrazine. In presence of with hydrazine you get addition elimination, and after that you boil this in a basic solution of ethylene glycol, and that will also do the same thing. You are going to form an alkane. Whatever group you are having over here, aliphatic, aromatic, it doesn't even matter. But yes, you will be having your you will be having your alkane. And yes, sir, because I have used hydrazine over here, so nitrogen will be released, and because this is just reaction in acidic medium, so here water is your byproduct. I hope everybody is clear. Chalo. Perfect, guys, perfect. Moving next, sir, done. Yes, beta. Preparations of alkane done, and with preparations of alkane we have done so many reactions also. Chalo. Moving forward, next is chemical reactions of alkane. Preparation of alkanes done. Now you have to summarize those reactions with your fingers. Sir, with alkyl halide, zinc in acidic medium, and then sir, Wood's reaction first. Second one was you have used unsaturated hydrocarbons. So third one was beta, third one broadly, third one was the third one you have used sodium salt of carboxylic acid, two ways, sir. Soda lime, sir. RH, sir. And then, sir, electrolysis, sir. Remove one C, sir, and then form a dimer, sir. And after that, sir, broadly it is from carbonyl compounds. Carbonyl compounds you can use Clemenson and Wolff-Kishner. Now this is the way you should keep them here. Moving, sir, the internal detailing, beta, internal detailing, if you can, definitely you can revise. Else, the internal detailing sometimes get out of your mind if you're reading it for the very, I mean, not first time obviously, but yes, rather if you remember less of them, so don't try to take everything out of it, but yes, take the zest out of it. Chalo, moving forward now. Sir, chemical reactions of alkane. So the very first chemical reactions of alkane is the substitution reaction. Now, what does substitution mean? I will remove one hydrogen from an alkane and then I'll be added. So that is known as a substitution reaction. Sir, halogenation can also take place, nitration can also take place, and sulfonation can also take place. Because nitration and sulfonation only take place at alkane with number of carbon atom. They can't be subjected on an alkane with less number of carbon atom. Why? It is an industrial fact. So therefore, I am doing nitration of 3 carbons. I mean, not one. You should have at least few carbon atoms. Now, what does nitration mean, sir? This is common sense. If I use concentrated HNO3 at elevated temperature, you cannot care about that temperature. Sir, NO2 will be added, will be substituted rather. Sir, it can substitute at any place, sir. So it can be substituted at this carbon, it can be substituted at this carbon. So you'll be having two products, sir, because you are using an elevated temperature, sir. So carbon-carbon bond can also be broken. Why? Sir, carbon-carbon bond can also be broken at high temperature, sir. So if, sir, one member can be broken, sir, and if one member can be broken, then you can have two member nitro compound. Sir, if both the members are broken, then you can have one member nitro compounds. Not very important, but yes, nitration of alkane can also take place. Similarly, sulfonation can also take place. What you require for sulfonation, a strong form of sulfuric acid is oleum, which is H2SO4 plus SO3. Now, technically, because nitration, concentrated HNO3, apart from being a strong acid, it is also an oxidizing agent. Rather, that is not a case with sulfuric acid. So even if you use oleum, the reactivity of 3-degree hydrogen is highest. So this 3-degree hydrogen is removed with OH minus of sulfuric acid, and you get your bisulfate substituted product as in HSO3. I hope everybody is clear. Chalo, perfect. Not very important, sir. Then what is more important? Beta, this is more important. What? Sir, halogenation. Sir, what is halogenation? A simple substitution which you know from your class 9, 10th. Sir, if you have alkane, try to react with any halogen. What halogen you prefer? Technically, sir, we prefer Cl2 or Br2. Why? Why we prefer Cl2 or Br2? Sir, we prefer Cl2 and Br2 because, sir, if we take no F2, sir, reaction is so violent. Why it is violent? Because, sir, F bond F. Sir, fluorine is very small. So these lone pair of electrons, they have so much of repulsion that this F2 breaks like anything. So this F2 breaks and gets substituted like anything. So this reaction becomes very violent. So obviously with F2, reactivity is very large. But because the reactivity is so large that such reaction become hazardous. So we do not do fluorination. Yes. Chlorination and bromination we definitely prefer. So Cl2 is better, Br2 is better, and these we definitely prefer. Now, technically, sir, I bond I has such large bond length that we do not do iodination also generally. Why? Sir, because this reaction is very lethargic. This reaction is very slow, so industrially doing this doesn't make any sense. So now we know that chlorination and bromination happens easily, and hence industrially only this is done. Now, what else, sir? Some extra details, sir. Because you use chlorination or bromination, you do this either in elevated temperature or sunlight. That means the reaction is again homolytic fission. The fission is again homolytic over here. Sir, homolytic fission take place, you can have your alkyl halide. But if you take alkane in excess, obviously the mono substituted product is more. But if you take chlorine in excess, then sir, homolysis can take place n number of time. So I can remove one H, mono substituted. I can remove another H from this mono substituted, sir, di substituted. Another H, sir, tri substituted. Another H, sir, tetra substituted. So this becomes a problem because you cannot have a specific alkyl halide. So this becomes a problem for halogenation. Now, what else, sir? What is the mechanism? I hope we have already, I mean, not written, but that's why I've brought you this. That first, chain initiation. As in, first X2 break and radical is formed, then this radical undergoes chain propagation. But here also, like Wood's reaction, that was also homolytic. Sir, it will have variety. What variety, beta? Sir, this can do chain propagation also. That means radical transfer. Sir, this can also undergo dimerization. The ethyl radical that has formed can dimerize also. So the ethyl radical that has formed can undergo sorry, disproportionation also. So the same thing will happen over here also. But if you are using alkane in excess, then the possibility of this mono-substituted product increases. And what are the chain termination steps? Sir, whenever radical will meet radical, chain can obviously terminate. And because in chain termination also, sir, the Cl, sir, the alkyl radical and Cl radical can also undergo chain termination. Hence, if you take more of alkane, then mono-substituted product dominates and becomes the major product. I hope everybody is clear. Now, let us quickly finish the points of relevance during halogenation. Okay, sir, let us do it. What are the point of relevance? First, I've already discussed. Second, reaction that takes place at high temperature in presence of sunlight is homolytic. That I have said also 2-3 times, and I hope you now know it is important, sir. So this is also important. Now, what is the order of reactivity? Sir, free radical is formed. So which free radical can be formed easily? 3 degree. So which hydrogen will be most reactive, sir? Beta, obviously 3 degree hydrogen. After that, 2 degree hydrogen, and least will be 1 degree hydrogen. But with this, you should know a technical fact also. But this, you should know a technical fact also. What technical fact, sir? Beta, we definitely know 3 degree hydrogen is more reactive. But with chlorination, sir, Cl radical will also have some tendency to react. Similarly, Br radical will also have some tendency to react. So that gives you the specific reactivity. That gives you the specific reactivity. So with Cl2, somewhere around 300 degrees Celsius, obviously 3 degree hydrogen has more reactivity. But how much times more? If you take 1 degree hydrogen as a reference, and if 1 degree hydrogen is reacting 1 times, then during chlorination, 2 degree hydrogen reacts 3.8 times. 3 degree hydrogen reacts with a faster rate, but how much faster? Sir, 5 times of 1 degree hydrogen. So taking 1 degree hydrogen as a reference, this is the relative rate of chlorination with degree of hydrogens. Sir, similarly with bromination, sir, if 1 degree is reacting with 1% rate, then 2 degrees is reacting with 82 times faster. And so 3 degree reacts 1600 times faster. So that's why during bromination, you do not even have to worry. If you have 3 degree, just make 3 degree the major product. But then you have to worry during chlorination. And loads of times, beta, mains has done this. And I am telling you, loads of time NEET has also done this. So let us do some calculation for the percentage yield of product, which I have written here also. But let us understand with this with an example. I will not be taking much of your time, which I've already said, and that's why I have done these things for you. Although it took time, but still, for you, anything can be done. If it is helping, sir, I am there. And I'm showing how I'm there with you. Chalo, come on. Sir, I have propane, sir. Okay. Sir, do chlorination, sir. Okay. You have already told, sir, 1 degree, 2 degree, 3 degree. Any can be formed, sir. Okay, then form it. So let us remove these pink color hydrogens. Sir, they will be 1 degree. One of the student was asking how to calculate degree. So with hydrogen connected with a carbon, which is directly connected to 1 degree carbon, is a 1 degree carbon. So that means these are my 1 degree carbons. Okay, beta. How many of these 1 degree hydrogens you have? Sir, 3. If you remove any of one hydrogen, what will be your product, sir? So the product will be this 1 chloropropane. If you remove from here also, here also. So how many possible number of hydrogens you have who are willing to get substituted? Sir, 6. And during chlorination, with what speed they will react? Sir, with 1, let's say they will earn 1 rupee. With chlorination rate is 1 is to 3.8 is to 5. So let's say 1 degree hydrogen will earn 1 rupee. So 6 1 degree hydrogen will earn, sir, 6 rupees. Next, sir, I have this 2 degree. How many 2 degree hydrogens you have? 2. both of them will react with what speed? Sir, 3.8 rupees each will earn. So 2 will earn how much? Sir, 7.6 rupees. So now this way you can even give the percentage yield of product. So this is earning 6 rupees, this is earning 7.6 rupees. So what is the total amount? Add them. Sir, total is 13.6. So what is 7.6 of 13.6? Do the percentage. So the product formed here is 55%. So ultimately this will be your major product. Although you can definitely see this can change. So if you increase number of carbon, you cannot blindly say that 2 degree or 3 degree will become major product. You have to calculate. In JEE mains, loads of time this has come. Beta, really important for you as well. I hope everybody is there with me now. That how to calculate percentage, I have given this formula also. Amount of product produced is equal to relative rate, as in chlorination 3.85, and the number of hydrogen present of that particular type. I hope everybody get it. Chalo. Moving to sir, that means you said fluorination is not done. Okay, sir. Iodination is also not done, sir. I told you it is slow. But sir, can we do something to make it fast? Yes. And even NCERT gives this detail. So make sure you remember this. What detail does NCERT give? NCERT says that definitely alkanes with iodination react very slowly. That means this reaction is highly reversible, not at all going in forward direction. So very, very, very limited amount of alkyl iodide is produced. Now, sir, but we have a trick. What is that trick? So use Le-Chatelier principle. So if I have any facility of removing product, or rather adding reactant, so what does Le-Chatelier principle will feel? Sir, if you are removing product, my equilibrium will be disturbed, and in order to oppose, I will try to produce more product. So if I remove HI or I add I2, reaction can proceed in forward direction, and in order to do this simultaneously, I can have a oxidizing agent like HiO3, mercuric oxide, nitric oxide, etc. These are, nitric oxide is most famous for you. So they shift the equilibrium forward. How? Just nitric oxide is most important for you, beta. That this nitric acid can react with HI, so it's a product removed. Nitric oxide is an oxidizing agent, so it will oxidize I minus to I2. Sir, reactant reduced and I2 produced. Sir, so double Le-Chatelier principle will work and reaction will be forced to move in forward direction. I hope everybody is clear. Yes, byproduct with nitric acid is NO2 and water. I hope everybody is clear. Chalo, perfect. Perfect, Anurag. Chalo, perfect. So people are there with me, yaar. Come on. Good. Perfect. Chalo, moving forward. Now, next is, sir, combustion. Combustion, we know, sir, if I have alkane of molecular formula CnH2n plus 2, then sir, oxidation as in reaction, combustion as in reaction with oxygen, and what will be formed? Sir, CO2 and H2O. So this stoichiometry also you should learn. Obviously you can balance also, but yes, definitely learn this, that combustion reaction is always exothermic, so you can have these stoichiometric relationship with thermodynamic principle as well. So definitely a famous reaction. But what is famous for us in organic chemistry? Sir, if you try to burn me, I'm an organic compound, so I'm not inflammable. So I will be burning in phases. Like for example, the day I will be gone, people will take me to some wood. Will I catch fire instantly? No, sir. Some ghee has to be added and I will at least take 30-40 minutes to blow up. Why? Sir, because I am not inflammable. So similarly, organic compounds are also not. So definitely how this, yes, but sir, all those petrol and all, because they are proper hydrocarbons. I am saying organic compound. I am an organic compound, not hydrocarbon. Obviously, hydrocarbons are quite inflammable. In fact, they are used as a fuel. And why I was saying exothermic, because the amount of heat released per gram of these hydrocarbons gives the value of their calorific value. If 1 gram of any compound can produce such large chunk of heat, then that particular fuel is good for us. So that gives the calorific value, a part of your thermodynamics. Coming again over here, sir, what is important apart from beta? Combustion must be taking in phases. That's why I was giving my example. Our combustion will also take place in phases, so their combustion will also be taking in phases. Yes, their phase would have been taking very less amount of time because they are inflammable. What does oxidation mean, sir? Beta, oxidation mean addition of oxygen. The basic definition of oxidation works beautifully here. Why? Let's say I have an alkane. If I do first step oxidation, so sir, remove one H and substitute OH. So what you get, sir? Alcohol. Do that again. The second step oxidized product, sir, remove second hydrogen. Sir, one carbon having two OH on the same carbon forms a geminal diol. The geminal diol are unstable and they dehydrate. That means you have formed a carbonyl compound. Sir, this carbonyl compound is still having two hydrogens, so make the next oxidized product. Remove one H, substitute OH. Sir, this becomes a carboxylic acid. But sir, this guy still has H, so make the next oxidized product. Sir, both OH. So again, case of diol, sir, gem diol, sir, remove again water, sir. So this is nothing but CO2 and H2. That means it is completely burnt. So what does completely burnt mean? Keep on replacing H with OH. Ultimately, you land here. Sir, but what are the in-between products? If we discover from the mother nature, if we discover some reagents which can move my reactant not to the final product, but to an intermediate product, then you can definitely understand this, that sir, you can have various type of organic compounds. Just think that if you convert your ethane into ethanol, you will be billionaire on the same day. But yes, you should work on that. The catalyst which will be doing that will be quite expensive. So let's say you mysteriously discover that catalyst, then definitely, sir, this reaction will definitely mean a lot industrially. Now, sir, then combustion, sir, we know. What is incomplete combustion? Beta, use less oxygen. So, sir, then what will happen? Beta, if you use less oxygen, then just like the burner of your kitchen, where if after the burner of your kitchen has gone old, the supply of oxygen limits, and when the supply of oxygen limits, you get the black layer on the vessels of your home. Why? Because you have this unburnt carbon, which is nothing but carbon black. When it is happening, sir, when you have limited supply of oxygen, so technically this unburned carbon is remained. This is the basic reaction, the balanced reaction, which definitely everybody should know. And sir, what about the reagents which can do controlled combustion? Again, very important. If you want to stop at alcohol, use heated copper at 300 degrees Celsius, or rather 250 degrees Celsius and 100 atm pressure. Learn this thing, NCERT fact. If you want to stop at aldehyde or carbonyl stage, then use molybdenum oxide, MO2O3. MO2O3. You use MO2O3. And if you want to stop at carboxylic acid stage, then use a acid derivative of a metal. Not all metal. Specifically, this is manganese diacetate. So you can form the corresponding carboxylic acid. If, sir, we have already seen, sir, in case of oleum, that 3-degree hydrogen are very reactive, because alkanes are technically paraffins. They are very least reactive, but 3-degree hydrogen, sir, is very reactive. I mean, not that much, but yes, if you compare with the basic alkanes, which are not at all reactive, 3-degree hydrogens are very reactive. That's why if you use the strong oxidizing agent, which you know from class 9 10th, which is KMNO4 or K2Cr27, the basic D block oxidizing agent, which are rather very strong, then those oxidizing agent can only reduce 3-degree hydrogen and can turn that 3-degree hydrogen to alcohol, a very famous reaction of NCERT. I hope everybody is clear. Now, these are the reactions with which you can relate this. So if I have methane, methanol with copper, formaldehyde with molybdenum oxide. Sir, if I have higher alkanes also, then if I use manganese diacetate, so I can form corresponding carboxylic acid. And if I have a 3-degree hydrogen bearing alkane, then that can be converted to corresponding alcohol. I hope everybody get it. Very important reaction, beta. I am telling you, this page will give you one question. Moving forward now. Sir, some basic more reactions of alkane, sir. Next is isomerization. Whatever carbon chain you are having in alkane, just break one carbon, make it branch. Sir, how many branch? Beta, do all the possible drawing of isomers. All the possible isomers will be your product. How does this isomerization can take place? Using reagent which is anhydrous AlCl3, the one which we use in Friedel-Crafts reactions in presence of acid. I hope everybody's clear. Next. Sir, you can even make alkanes as aromatic benzene. How? First, in order to make that aromatic benzene, the cyclization has to take place. Sir, Bayer strain will happen. No. Six-membered carbon ring is free from any type of Bayer strain, so use at least six-membered alkane. Six or rather more. Sir, after more, the benzene will start having that substitution. So if you use heptane, toluene will be formed. uh, if you have used hexane, benzene will be formed. Sir, what are the reagents? Very famous NCERT fact. These 3D series oxides, what are they? Vanadium oxide, molybdenum oxide, MO2O3, here also famous. MO2O3, vanadium oxide, and chromium oxide. Vanadium oxide, molybdenum oxide, chromium oxide. Elevated temperature of somewhere around 500 degrees Celsius and 10 to 20 atmospheric pressure. Do not be very much bothered about temperature pressure. Yes, it should be high. If you can recall, this is NCERT fact. Please do. Moving forward. Now, sir, what else, sir? Yes, beta. Yes, beta. What else? Reaction with steam. Very tuchu, very small reaction, but yes, inorganically very good reaction. You can react all the alkanes with steam. You can react all the alkanes with steam. That's why saying steam, because this reaction take place at 1000 degrees Celsius with nickel as catalyst. And what is produced? A mixture of carbon monoxide and hydrogen, which is also called synthesis gas, water gas, or syngas. Why syngas? Because this gas is used to form many other compounds in industry. What are the reactions? Yes, but leave them for JE. For you, only learn this much, more than sufficient. Sir, what else? Next is pyrolysis. What is pyrolysis? If you kick me from the terrace, let's say from 40th floor, one thing is for sure, I will die. But one thing is for sure, bones will break. Sir, but how many and what bones will break will depend on the day. Sometimes I will fall from head, sometime I will fall this. Ultimately, I am going to crack. Bones are going to break. Similarly, we do cracking of hydrocarbons. At extreme and elevated temperature, carbon-carbon bond is going to break. How? Sir, it can be n number of possibilities, so draw all those possibilities. Like for example, if you subject to that thermal high temperature, what is that high temperature? Generally 500 degrees Celsius. So let us take, I have broken hexane. Sir, hexane can form hexene also, hydrogen gas also. Sir, hexane can broken to butene and ethane. Sir, propene, ethene, methane. So you just have to check the molecular formula, make the corresponding alkenes and alkanes the fragments. Sir, can this be controlled? Yes, using a fractionating column it can, but yes, fractionating column and burning will require money, and that plant is called, where you buy your crude oil and do the processing in that plant, is called Mukesh Ambani. As in, these are the job these refineries do for us. Private is obviously, and IOCL, BPCL, HPCL. Yes, it is quite a holistic process, but yes, this is the basic for it. Sir, for example, the major component of kerosene oil is dodecane 12 carbon chain, subjected to a temperature of somewhere around 700 degrees Celsius with nickel, platinum, palladium catalyst. This also breaks, but using systematic fractionating column, you can restrict this to be broken into heptane and pentene. Obviously other products, but yes, they will be major products, and these are the major components of your petrol. So kerosene, when worked, forms petrol. That's why kerosene is cheap, petrol is expensive. Although in previous trucks people use kerosene also, and that's why this BS configuration has came into place, so that you can't use kerosene, because obviously they will have very less, they'll be producing very much unburned carbon beta. So I hope you get this also. Very beautiful reaction, industrially very famous reaction. Now moving forward, I hope everybody is with me on this. I hope everybody is with me on this. Guys, I need motivation. Who is there with me? Yes, 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 yes. Who is still learning with me, iterating reactions with me? Quick, quick. Yes. Okay, 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 okay. हाँ, efficiently. Yes. Okay. Anupam, thank you. So I got okay. Neha, Khushi, Hasani. Are there are many people here. Khushi. Okay, I got it. I got it. There are many. Thank you. Thank you. Clear, sir. Perfect, beta. Perfect. I'm loving it. I thought that people, great, yaar. Come on, come on, come on. Good. So whatever amount of time investment I have done, I guess this is going to be very much fruitful. Perfect, beta. Thank you. Great. Chalo. Keep this momentum going, beta, because we will be taking lot of time. है ना? Chalo. Quick. Now, sir, from alkynes. So what from alkynes? Sir, now this means, sir, alkanes we have finished and now we have moved to alkenes. Now we have moved to alkenes, sir. Okay, sir. So for alkenes also, what we are going to read, first thing, sir, preparation. Second thing, sir, reactions. So let's start, sir. Okay, beta. Let's start preparation. Okay, sir. First is from alkynes. Sir, we know from alkanes only, sir. Alkyne do partial reduction. Yes. So alkyne can be partially reduced to alkene, but here the reagents are very specific. If you use Lindlar's catalyst, then you get alkene. But what form of alkene? Cis alkene. Why? Because you have used poison catalyst. Ultimately, hydrogenation could have done complete reduction, but I want to restrict it. And how I am restricting it? By adding catalytic poison. What is this catalytic poison? With palladium, you definitely need a catalyst, or else hydrogenation will not take place. But I want hydrogenation to happen in a very limited amount. So I have to poison my catalyst. How? What you can use? You can use sulfur compounds, limestone, which is calcium carbonate, or quinoline. You can also use barium sulfate in place of, if you do not get any sulfur compound, then this barium sulfate is very easy to fetch. Now, sir, that means this is my Lindlar's catalyst. Yes, sir. How to learn this? That it forms a cis, because, sir, poison is a good thing or bad thing? I mean, just a mnemonic to learn. Poisoning is a good thing or bad thing? Bad thing. Bad thing in English is sin. So don't commit that sin to poison any person. So sin, cis alkene. Sir, I have Birch reduction. What is this Birch reduction? Again, partial reduction using metal. What metals are reactive metals? Sodium in liquid ammonia will again do partial reduction, but will transform into a trans alkene. So that means here syn addition must be taking place, and here trans addition, yeah, or anti addition must be taking place. Although if you do not learn this, but at least learn that cis and trans alkene is produced. If nothing is mentioned, then obviously alkane will be produced, because you will not be limiting. Once you just do catalytic reduction, directly alkyne will convert into alkane. Easy, sir. Linda's also done, sir, but Linda's is there in carbonyl group in class 12th organic also. So let us combine that also. If you have acid halide, use the same Lindlar's catalyst. This acid halide will also be reduced, sir. X will be gone, H will come. Partial reduction, sir, because this carbonyl compound can even reduce to alcohol. But sir, this is partial reduction, so only one step. Why? Because, sir, I have used poison, and this reaction is known as Rosenmund reduction, naming reaction. Sir, LiLH4 can also do this. LiL4 can also reduce alkyne to alkene via anti-addition. LiAlH4 can also reduce alkyne and alkene. Alkyne also and alkene. This should be and, not two, beta. It should be and. It should be and. Do not confuse yourself. So let us be quick. That LiLH4 can also reduce alkyne also and alkene also. So this is not a preparation of alkene, but yes, sometimes people get confused. So LiLH4 can reduce olefins. So alkyne or alkene will form corresponding alkane. Let us keep it that ways. Now, moving forward. Sir, Next, sir. Sir, first preparation of alkene is very easy, sir. We know that. Just that Lindlar's catalyst and bridge reduction, that knowledge is important. Now, what else, sir? Beta, you can also form alkenes from alkyl halide, a topic from class 12th also, here also. So let us explore this also very properly. What is it, sir? You can do beta elimination. What is beta elimination? E2 mechanism. What is it, sir? Very easy. Let's say I have alkyl halide, sir, functional group is halogen connected to carbon, so that becomes alpha carbon. The next carbon to alpha carbon is beta carbon. So I need a base. What base will do? Base will give electron to this hydrogen. Sir, why it is giving? Because this guy is asking for electron. This carbon is very much pressurized. It will also ask for electron from this carbon, and ultimately who gets the heat? Sir, if any government will increase taxes, who will pay that taxes? The weakest section of the society and the disciplined section of the society, all the working class people. So who is that weakest section of society? It is hydrogen. So ultimately hydrogen will take that heat because hydrogen electron is demanded over here. So if a base is present, then that base will offer its electron to this beta hydrogen. The electron of beta hydrogen is transferred to this alpha carbon, and this sigma bonds transform into a pi bond, and you get your alkene. This mechanism is nothing but a one-step process. Beta carbon hydrogen is removed, so this is called beta elimination or simple E2 mechanism. What are the byproducts? Sir, BH, base with hydrogen, and this X is removed in form of X minus. Sir, what is the base? The most famous base is alcoholic KOH. Why not, sir, basic OH minus? Beta, because basic OH minus is a weak base. RO minus, R will apply plus I effect, and alkoxide ion is rather a strong base than hydroxide ion. So in order to create that alkoxide ion, I use alcoholic KOH, which will give me much of RO minus. These are the ways by which alcoholic KOH will be written in your paper. I hope everybody is with me. Moving forward, sir, some more fact, sir, because this will relate chemical kinetics also, and yes, very much asked also. So E2 mechanism, sir, what is order of reaction? 2, because this is one step process. So alkyl halide and base, the more you use, the more you have rate of reaction. So order is 2. Sir, how many molecules you have? 2. So molecularity is also 2. Now, what is order of reaction? Sir, order of reaction is an experimental concept from chemical kinetics which says rate of reaction is directly proportional to concentration of reactants raised to the power stoichiometry. Now, what is this stoichiometry? The coefficient? No, sir. This 1 and 1 is experimentally determined, sir. So that's an experimental concept. Yes. When you write the mechanism, how many reactant molecules you have used? 2. So molecularity is a theoretical concept which we determine after this experimental concept. But yes, how many reactant molecules? Theoretically we had 2, so molecularity is also 2. Now, very important point, beta, during beta elimination, what hydrogen is removed? Sir, beta hydrogen. But what beta hydrogen? Which is exactly opposite. That's why I've made this picture also. The position from which halogen is removed, hydrogen must be opposite. Why? Sir, because base is electron rich, this is electron rich, halogen. Sir, minus minus will repel each other, sir. That's why base will only be feeling better, not repulsion, from that hydrogen which is exactly opposite. So trans hydrogen always. Beta, in chemistry, one thing we definitely never write. What is that thing? This. Wherever I am, you just check, do we write always? No. So here we have written always, and I hope I have given you the common sense that why that always I have given. Now, perfect. Moving forward, sir. Now, because sir, you are focused, on the what hydrogen I will be removing. That means I am being highly specific about the reactant, that reactant I use, that reactant I will not use. Just go by the English, beta. So I am being highly choosy about reactant. If you are being choosy about the reactant, you are technically termed as a stereospecific reaction, because I am interested in the three-dimensional chemistry also. So I'm being stereospecific also in E2. Now, the product I can form, sir, I may have 2 beta carbon. So which beta carbon hydrogen will be taken? which will form strong stable product. So I am choosy about the product formation also. Such reactions are called stereoselective reaction. Most of the students miss this, so I have a trick for you to remember. The trick is English. What English? If I am being specific that I will not react with you, I will react with you. I will not go out with you, I will go out with you. I hope you can relate. So I will not go out with you, I will go out with you. You are being specific about reactant before going to a party. You are picking, I will go with you, not go with you. That means you have options. So you are specific. So if you are reactant choosy, you are specific, stereo specific. And if you are product choosy, then you are stereo selective. I will select you to be produced and I will select you not to be produced in larger amount. So I hope you know this basic definition of stereo specific and stereo selective. So please remember this R and P. Clear? Now, sir, now this is very easier, sir. Sir, alkyl halide first, sir, halogen has to go, sir. So which halogen will go first? Sir, where bond length is more? So iodide most, and in fact, I have not written fluorides. Why? Because bond length is less. Technically, they do not do beta elimination. So that means alkyl fluoride will never go elimination. With another mechanism, E2 never. Alkyl fluoride never undergoes E2 elimination. Some other elimination that will come now. Sir, degree, sir, you have already told what alkene will be produced, most stable. How you can stabilize alkenes are hyperconjugation or inductive effect. So 3-degree alkyl halide will be more reactive. Why? Because this will form a rather stable product. Stable product, sir, once stable alkene is formed in more percentage, that product is called Sidzeff product, because this has been, obviously, it is stereoselective, must have been identified by some scientist. And what is that scientist? It is Sidzeff. So the product is also called Sidzeff product. Moving forward, again written that says a product more stable alkene becomes major product. Sometimes in some references you also find instead of Sidzeff they say Zitzeff product. I hope everybody's done. Moving forward now, sir, you have said, sir, fluoride also eliminates, sir. Yes, but not by E2. But sir, then we should know, because we are not learning only alkanes. So we are learning organic as a whole. Yes. So let us quickly jump to alkyl halides. Yes, beta. If you have alkyl fluoride, then sir, alkyl fluoride will never undergo elimination. I didn't say that. I said they will never do E2. They can eliminate. How, sir? First of all, if you have this alkyl fluoride, you use a base. Okay, sir. But beta, this C bond F is very less. Sir, that's why we have seen this was not giving E2. But beta, can base do its job? Yes, sir. What was the job of a base? To give electron to beta carbon. You give it. Sir, give. Sir, carbanion will be formed. Form that carbanion. Sir, but carbanion can be formed here also, here also. Go to your common sense. Sir, carbanion is electron rich. Don't give it substitution, sir. So 1-degree carbanion is better than 2-degree. 3 degrees never formed. So sir, form that 1-degree carbanion. Moreover, sir, this fluorine will stabilize that carbanion also. So more be the electron withdrawing group, more will be the electron withdrawing group. Sir, this mechanism will be favored. What is this mechanism? I'll come to the name. Obviously, you can see this, but let us conceptually frame it. Carbanion is formed, sir. Sir, that means this is the first step. Yes, sir. How do you know it? Chemical kinetics or experimental? So please, you should learn this now. So that means this is the first step of the mechanism, and here the reaction can take place very fast, because sir, this carbanion is loving to be getting formed, because it is stabilized also by electron withdrawing group. Okay, beta. Now, sir. Now after this, my friends, this carbanion will take very long time. Why? Sir, because this bond length is very difficult to be broken. So after sufficient amount of time, this electron will go, this fluorine will agree and will finally leave, taking lot of time, hence a slower step, and finally you will be getting your alkene. Now, sir, but this alkene is less substituted, sir. Yes. but still formed, sir? Yes. Why? Because I am not saying less substituted product is formed. This is the only possibility, and it is formed because this carb anion is stable. So technically, this forms an alkene which is less stable but more probable. So whenever less stable product is formed, that product is not called Sidzev product. It is rather called an Hoffman product. Now, that means, sir, let us name this reaction. This mechanism is called E1CB. Why? Because the slowest step is this, which is having one molecule, reactant molecule, so molecularity is 1. But sir, this is not reactant, sir. So if you just put this reactant in equilibrium constant K reaction from here, sir, the more you get this reactant, the more you have base also and alkyl fluoride also. So order of the reaction will be 2, but molecularity is 1. This is the famous reaction which gives a clear-cut distinction between order and molecularity. So order of this reaction, steps is 2, molecularity is 1, but order is 2. Why 2? You can definitely see it from this. And therefore, this is also called E1CB because here molecularity is 1, so it is a unimolecular reaction. So E1CB is elimination unimolecular, and RO minus is my conjugate base. I hope everybody is clear with this. And sir, this will form an alkene which is less stable. You will get number of questions. Sir, why not attempting questions? Beta, it will be very easy for me to bring questions and beta attempt. I'm not saying that is not productive. That is, even I do this in most of my lives. This takes more energy. Why you are not doing it, sir? Beta, on Tuesday I'll again be doing a long marathon session, and in that long marathon session I'll be taking all these concepts and then we'll make you practice questions. Not from organic, because that will be an more extended session, more extended as compared to this one, because beta 21st is approaching. So we have to be on our best, and this is what we at PW NEET English are trying to do. Everybody, all of your teachers are doing it. So question practice on Tuesday or Wednesday. I guess on Tuesday you will be having chemistry long marathon. There I'll be doing just question practice. Okay. Chalo, let us learn concept today. Now, sir, then, less substituted alkene can form, sir, less substituted alkene is produced, but that is the probable product also, sir. So it is not the thing that a compound which is less stable it is forming. During such condition, there may be some reasons why that product is the only product. That's why it is formed. And once you compare an alkene with its more substituted alkene, if less substituted is formed in a larger percentage, then only that product is called Hoffman product. So even CB produces Hoffman product, true. Can I get Hoffman product with other scenarios also? Yes. What else, sir? Other cases of Hoffman product. And what is Hoffman product? When less substituted alkene is the major product. Although less substituted but major. Case 1. Sir, why case 1? Beta, that is also one of the Hoffman product, but let us explore another also, because there I have mentioned a mechanism name. Here I am only mentioning you will be getting less substituted alkene as major product. Case 1. When base is bulky, let's say the RO minus you have, that RO minus, that base becomes that alkoxide becomes a very bulky base. So technically I want to give electron to whom? Let's say if you have this alkene, then how many beta hydrogens you have? So this is my beta carbon, this is my beta carbon, and this is my beta carbon. Sir, if I remove hydrogen of this beta carbon, sir, the alkene will be more stable. But sir, this beta carbon, it is very much, it is, sir, 2 degree. And sir, I am a very bulky person. I can't go inside because, sir, I will have repulsion. So rather I just want to give electron. So why I will climb up the stairs and give you the parcel in your floor? Rather I will just come and give the parcel to your watchman. I will not climb up. I am fat enough. So if I am your delivery boy, I will not come to your floor. I will rather give it to your watchman. I will call you, hey, receive, I've gone. Hello? This is what the strong base is going. Sir, who is that least bulky? Obviously the 1 degree. And because that will be the least hindered, so least substituted alkene, because this guy will give H, double bond will come here. So this alkene is least stable, but still, sir, probable. So one type of Hoffman product. Case 2, when you have Conjugated alkene, because we are saying substituted alkene, that means we are only focusing on that alkene which is stabilized by either inductive or hyperconjugation. Do we have even strong electron donating groups? Yes, sir. Sir, resonance is even dominating effect than hyperconjugation and inductive. So if resonance is happening, then sir, I will form more stable product, but that more stable product will not be much substituted. Sir, where? Like this. Here, this is also beta, this is also beta. If this beta is gone, then whatever alkene you will be having more hyperconjugation. If this beta is gone, this will be having less hyperconjugation, but sir, it is conjugated pi sigma pi. That means it is resonance stabilized, but ultimately Sidzev said more substituted, this is not more substituted, and still this is getting produced. So less substituted, major product, Hoffman product. I hope everybody is clear. Next, sir. Beta, once the beta carbon itself is sterically hindered, very less famous. Most of the people do not know this. Sir, this is also beta, this is also beta. Agreed. This beta has no problem, but sir, this beta is having very bulky group. So let's say if you have an efficient base, even you have jaunty roads delivering you parcel, he can climb n number of floors. But if your floor is overcrowded, I can't approach your gate. So RO minus is not bulky, but that beta carbon is bulky. So how come I can enter, sir? It is repelling, sir. In such cases also, I rather prefer giving electron to that carbon which is not hindered. So this will also result in an alkene which is less substituted. Again, a case of Hoffman product. Last but not the least, when hydrogen is not present in opposite position, because hydrogen has to be NT. It is always condition for E2. Sir, technically, if you are given a question like this, then you have no problem, because question is not being specific reactant choosy. Question is not being specific about the stereochemistry, that this methyl and this bromine is on what side, it is not specifying. You form your product. What product? More substituted. So I have formed this product as major product. Why I'll form this is minor product, sir. So if reaction is given like this, where examiner is not stereo specific, you can form your SIDZF product. But if the examiner is the question is being about stereochemistry of the question, then sir, bromine here, this is also beta carbon, sir. That is also beta carbon, sir. So that will form more substituted. And bromine and hydrogen are opposite also. So I'll form it. Because first I need hydrogen in opposite direction. If hydrogen present in opposite direction, I'll remove it and I'll form the stable alkene. Hello? Sir, here bromine. Sir, this will form stable alkene, but bromine and hydrogen are on same side, sir. No, not possible. Even if I want to form major product, how the base will enter? Sir, base can only approach hydrogen, which is NT. So I will not bother, because you can form stable product, but hydrogen of yours is not NT. So this bromine and this hydrogen will go, and this product, which is less substituted, will be your major product, and this forms your Hoffman product. So here also SIDZF, in general also SIDZF, but if such case is there, then you form your Hoffman product. I hope everybody's clear, guys. Chalo, perfect. I have loads, sir. Chalo, perfect beta. Awesome. Moving forward. Next, sir, third. Very simple, sir. By dihalides, although NCERT specifically say vicinal dihalide, but this is what you should know. Even vicinal and geminal dihalide both can transform this reaction, that if you use zinc in either ethanol or acetic acid, you can form your corresponding alkene. Please make sure NCERT only mentions about vicinal dihalide, although with zinc in mild acidic condition, you can have vicinal and geminal both dihalides producing the corresponding alkene. I hope everybody is clear now. Sir, next. Sir, preparation of alkene only, but again this is from the chapter of alcohols. So relating and summarizing all the chemistry, all the important chemistry reactions for you now. Perfect. Sir, next thing is, sir, Elimination unimolecular, sir. E2 you have discussed, sir. E1 CB you have discussed, sir. Sorry, E2 and E1 CB, sir. Why not E1? Because beta, technically, although sometimes it does, but technically alkyl halide do not show E1. Technically, huh. Sometimes it may, but technically who shows E1? Alcohol. Why, sir? Because C bond, if you have C bond OH, beta, bond length of C bond O is very less, because sir, oxygen is also second period, C is also second period. That's why in case of alkyl halide, I have not even taken alkyl fluoride, because CF both second period element, sir, but C bond O is also second period element. Then why you are doing it? Because technically C bond O is not broken. But if you use acidic medium, then because of presence of that H plus ion, this alcohol can undergo protonation. What is protonation, sir? Okay, I'm not saying this C bond as it is breaking. It is not breaking. But in presence of acidic medium, this OH will become OH2 plus, and now this oxygen, who was in love with this carbon, but now this oxygen has become positively charged oxygen, which is already electronegative. So now this oxygen is mad, and this drastically mad person will now take the electron of carbon and will result in the formation of carbocation. Now I am not saying this is happening very easily. It will take time, just like fluorine removal took time, again taking time. That's why chemical kinetics also says that removal of water is the rate determining step which forms the carbocation. And because this is the slowest step, so whenever carbocation is formed, you will apply all those electron displacement effect. That means, sir, ring expansion can take place, rearrangement can take place. So all that condition, it can rearrange, it can undergo ring expansion, so all the possibility can take place, and this carbocation will be keep on getting stabilized. Point number one, that means rearrangement possible. Now, after this carbocation has sufficiently stabilized, because this carbocation can't further stabilize, this is the best possible carbocation in this particular case. So after this, whatever, sir, let's say I've used H2SO4 to create H plus ion. So the after removal of H plus, the conjugate base that you'll be having, that conjugate base will now offer electron to the beta carbon. Sir, which beta carbon? Again, now apply a Sidzeff rule. That beta carbon which will produce a stable alkene. And this is how elimination take place. But look over here, this is not a one-step process like E2, this is a two-step process. What is rate of reaction? Because, sir, first step is the slowest step, which just has only alcohol. So that means the rate of reaction is proportional to concentration of alcohol raised to the power 1. How this raised to the power 1? I know experimentally. After doing experiment, this is the theoretical mechanism which I have suggested, and according to this theory, what is the number of molecules in the rate determining step? Just one. So molecularity is also one, order is also one. I hope everybody is clear, guys. Chalo, perfect. Now, acha, let us move here. Now, sir, you have already told us it's a product will be formed. So, what type of alcohol will be good? Sir, 3 degree, then 2 degree, and in fact, beta, 1 degree alcohol do not even undergo elimination using E1. Why? Sir, because carbocation, 1 degree carbocation is not less stable. It is not at all formed. So, rather, 1 degree alcohol also undergo elimination using E2 mechanism, not E1. I hope you're getting it. 3 degree and 2 degree only undergoes E1 mechanism. Now, how this is proved by NCERT? NCERT uses example. What example? With 3 degree alcohol, NCERT uses only 20% acid, that too weak acid, phosphoric acid. With 2 degree, it uses higher concentration of phosphoric acid and temperature also more. And with in fact 1 degree alcohol, it uses strong acid, sulfuric acid, and temperature is also elevated. So this shows this phenomena, that what is the reactivity of alcohols at 3 degrees most reactive, 1 degree is least reactive towards elimination. I hope everybody is clear. Perfect. Next, mechanism also done. This all. Now a beautiful question, let us practice, everybody. Now let us hold for this question. I just bring some water, everybody. I said I will not give much question, but at least one question, because with this we are going to practice rearrangement. So quickly attempt it in your copy. Everybody take out your copies, quick, take out your copies and attempt this. Quick. Hmm. Take out your copies. Nahi, Muskan, rearrangement will happen. I'm giving a hint. And in fact, ring expansion will happen because which ring is free from angle strain? 6-membered. So whenever you have a carbocation next to a 4 or 5-membered ring, first think of ring expansion, then think of rearrangement. Quick. Quick, everybody. B? Beta, there is no option. What B? There is no option. I want everybody to at least spend time with their rough copy and if possible, give me the answer, the IUPAC name of the product. Giving you an hint, you have to do ring expansion. Again giving an hint, not once but twice. Why? This is J Mains 2023 question. Although mains didn't used to ask such questions, advanced do, but yes, mains also started. So a very important one to practice. No, Gaurav wrong. Try once more. Gaurav wrong. Gaurav wrong. No, Gaurav. It is not cyclopentane beta. Acha. Acha, 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 acha. Listen, listen, listen. Listen, listen, listen. See, just for 1 second, na? Because obviously do not wish to waste my time here, but your time also, why my time? I'm just giving you a hint. Answer is this: two cyclohexanes with double bond. Two cyclohexanes with double bond. Two cyclohexanes with double bond. Do it. Divya, not okay. Do it with pen and copy. It'll help you like anything. It will help. I'm not saying you should do such questions in your mains beta, but they will give you so much of confidence here. You will be able to not to do this question in the exam if comes. Perfect. Come on. No, Neha. It is not cyclopentane beta. It is not cyclopentane. That is what I'm saying. अच्छा आज तो मन भी अच्छा ओके I picked a wrong comment to read. Have you leaked answers? हाँ बेटा, I've leaked answer. Because beta, I want this with this session. I'm not interested in ABCD. With this session, nahi Gaurav, मेरे भाई, I'm not interested in ABCD. I want you to try the logic. That's why I've shown you the answer. Sir, doubt. Yes, Berlin. Oh, Berlin. Berlin. Berlin, ask your question. Berlin always reminds that song, na? Chalo. So, done with the heist. Theory explanation, right? Okay. Pentene again. Hasini still pentene, beta. Sir, theory explanation, right? Okay. चलो सर आपने मनी हाई सीरीज बेटा कम ऑन बर्लिन यार कम ऑन nobody can miss such series. GOT, money heist, these are sessions, these are phases of life once the season gets over, a void is created for some time. Then so obviously, yes. Chalo, chalo, perfect. Now let's start. Let's start. Cycle. Ha, Muskan. Now I have a winner. Chalo. What happens to superstar? Neha? Ah, now superstar is still saying octoanine. Superstar, what happened? Acha, bicyclo. Oh yes, superstar is giving perfect answer. Chalo. So why? How come superstar cannot do this? Come on. Now let us explore beta. Quick. Sir, the question says now beta. Please make sure you're listening to this. Hai na? Sir, this is OH. Sir, lone pair will go and undergo protonation. Once they are protonated, water will be removed. Sir, carbocation formed. Done, sir. But now, sir, this is a four-membered ring and this is a five-membered ring with carbon, the next carbon having positive charge. Which ring will expand first? Sir, four-membered, because four is more bare strained. So let's say this bond is opened and ring expansion will take place. So this four member will become five membered ring. So became five membered ring. Writing five membered like this is much easy. So this carbon is having plus. Sir, after ring expansion, do rearrangement. Sir, this is 2 degree. If this hydrogen goes here, plus comes here, so this will improve the degree. So I have got my positive charge here. But sir, now seeing this positive charge, this five-membered ring will also want to undergo ring expansion. And as I have told, carbocation is formed in the slowest step. Sir, because it is formed in the slowest step, so you have to give and allow this carbocation to undergo ring expansion rearrangement as much as it want until it is maximum stabilized. Sir, because this is plus, so now this ring can also open up. So let's say ring going here, positive coming here. That means that 5 will become 6-membered ring. So 5 has turned into a 6-membered ring. Here I still have a 5-membered carbons. Here you still have a 5-membered carbon. Sir, after ring expansion, give option of rearrangement. So beta, because this is 2 degree, if the transformation, sir, but now how come? Because here there is no hydrogen. Then beta, why you are thinking of hydrogen? Because this is 6-membered, that is still 5-membered. So this 5-membered ring has this carbon, which is just the next carbon. So why won't it will have an opportunity for ring expansion? Definitely. Yes, this bond can also break, this bond can also break, but yes, because of the picture representation, let me rather do ring expansion of this. So the moment ring will be expanded, the positivity will be going here. So that means that this is also 6, this is also 6. So both 6-membered ring drawn beautifully, positivity over here. Now sir, no profit of rearrangement. Then if no profit of rearrangement, that means carbocation is stable enough. Now ask your base to give hydrogen to beta carbon. Which beta carbon will take hydrogen? This. Why? Because this is how you get maximum substituted. How? So 2 hydrogen, 2 hydrogen, 2 hydrogen, 2 hydrogen. So how many hyperconjugating hydrogens I have? 8. So this will rather be your major product. Yes. I hope, I hope, I hope everybody is good. I hope everybody is good. Chalo, perfect. Perfect. I hope everybody is good. A very beautiful question to understand the logic of ring expansion and rearrangement continuously till the point maximum stabilized carbocation is formed. I hope everybody is good. Chalo, moving forward. Now, next, what else, sir? Now comes as beta the addition reaction. So addition reaction of alkenes. So if I have alkene, sir, alkene will definitely can have those addition reaction. Why? Because the pi electrons will make alkene electron rich, and it can have any positive species, as in which is having electron deficiency. So any species which loves electron, as an electrophile, can attack and do electrophilic addition. So there are many famous reactions, but before those electrophilic addition, let us do some basic addition of hydrogens. The LiLH4 catalytic hydrogenation, and this And although if in your question, because sometimes NTA plays with this, because we have an habit of learning, that PD slash C is always Lindlas catalyst. No beta. Sometimes you can even J has done this a lot of time. Yes, NEET I have seen this happening less number of time. But beta, this is palletized charcoal. This is not Lindlas catalyst. Technically, it is palletized charcoal, and palletized charcoal in presence of excess of hydrogen can reduce alkene also to form corresponding alkane. Obviously, these are the famous reducing agent, but palletized charcoal and Lindlas catalyst are different. Sometimes the question may write Lindlas catalyst also PD slash C, but they give information with options or something like that. But this is palletized charcoal. This is not Lindlas catalyst. What is Lindlas catalyst? I hope you know. Yes, sometimes the examiner gives Lindlas catalyst mentioning as PD slash C, but not always. JE has done that, Advanced has done that so many times, but yes, you should know this thing, very important. Now, moving forward, what else? Sir, now, alkene can have addition of halogens also, sir. So, bromine addition and chlorine addition, again, F2I2, not famous. So, you get your vicinal dihalides. Sir, why you have written like this? Because beta, generally H and H is a syn addition, but X and X are large enough, so they are trans addition or anti addition. Now, if they are anti addition, sir, shall we know some more facts around it? Yes, regarding bromine, you should know, because bromine is a non-metal which exists as liquid at room temperature. So this bromine is coupled with a non-polar solvent which is CCl4, and bromine and CCl4 is known as bromine water. Although there is no water, but it is termed as bromine water, and it has a color. It is a beautiful red orange colored liquid, and once if it is present, color will be present. If it has reacted and transformed itself to form a vicinal dihalide, then it has gone, so color will also be gone. So decolorization of bromine water becomes a test of unsaturation. I hope everybody is clear with this also. Moving forward, what is the mechanism, sir? What is the mechanism, sir? Because mechanism also, mains have asked it so many number of times, and I definitely feel for NEET aspirants also, at least you should know this. What? First of all, what happens is, because you have already told us our alkene is electron rich. So this electron rich species is attacked by an electrophile, sir. Where is that electrophile? Beta, bromine plus, or rather any X plus. The X2 can break and form X plus and X minus. So this X plus, which is electron deficient, will attack. Although we say this is attacking species, but beta, we know who moves, sir. Electron move from where? From higher concentration to lower concentration. So these electrons are moving from higher concentration to lower concentration. Let's say this bromine once approached, sir, here a cyclic brominium positive ion, a cyclic brominium cation is formed. I'm not saying bromine is getting attached. Sir, the electron cloud is approaching bromine, and therefore the plus minus attraction will bring bromine closer to both the carbon as a unit. And this cyclic brominium cation has formed. What else, sir? Now, if Br plus has attacked, whoever minus is available. Why I'm saying whoever minus? Because if you have just used Br2 in CCl4, then definitely minus is available, minus is Br minus. So Br minus will attack, but where, sir? Because that side is already occupied, so it will attack from the other side. So it is attacking from the other side. Yes, it can attack here also, it can attack here also. Wherever it will attack, the electron will definitely move. So if attack here, one bromine here, another bromine here. If it is going here, one bromine here, another bromine here. Ultimately, sir, this is anti-addition. Ultimately, this is, sir, anti-addition. And because there is anti-addition, that means that stereochemistry you also have to apply. So people have done experiment. Sir, whether a compound is dextrorotatory or levorotatory can only be determined through experiment. I hope you know this. You cannot identify whether a compound is dextro or levo. RS configuration you can assign theoretically. But sir, R does not mean compound is dextrorotatory. RS mean if R is dextrorotatory, then S will be levorotatory. If you are dextro-levo can only be determined through experiment. So we have done all these experiments and we have given a conclusion. GSA, Gaurav Singh Arora also has a conclusion for you. For these questions, they were started by JEE Advanced, but mains, they are in love with it. Your NEET people also ask it. Now, what is that trick, sir, to learn stereochemistry? Beta, trick is team. Trick is a word called team. What is this? Team. T-E-A-M. Sir, how to learn it? In case of transalkene, T stands for transalkene. In case of transalkene, if you have A, E is nothing, it's just for a rhyming. So if you have a transalkene, then in case of anti-addition, like bromine does anti-addition, in case of anti-addition, meso product is formed. I hope you got the logic. And sir, opposite also true. Yes, that's my team. Opposite also true as in if I am cis and then anti-addition take place, so product will be optically inactive. But why? Because of racemic mixture. Here product will be here in case of transalkene, if anti-addition will take place, product will be optically inactive. But what? Due to mesoform formation. That means because of internal compensation. And in case of cis alkene, anti-addition take place. I will just give a that rhyme here because I guess you will miss that. Giving rhyme here. In case of transalkene, anti-addition take place, so mesoform is formed. Product is optically inactive, but optically inactive due to what? Mesoform. In case of cis alkene, anti-addition take place, then you get a racemic mixture. Sir, how to think it? Beta, this is my reference, and as per this reference, you form this. Again, sir, again taking this as a reference, how? Sir, if you have cis alkene and instead of anti-addition, you have syn addition, then do the opposite. So cis was forming racemic mixture, so now cis will forming mesoform. Why? Just opposite. In case of transalkene, if you have syn addition, then you get a racemic mixture. That means, sir, ultimately alkene, if has formed addition product and the addition product is having an element of symmetry, then the product is definitely optically inactive. But optical inactive due to what? Due to racemic mixture or mesoform. This rhyme will help you decode it. Sir, give an example. It is an example. Like for example, yes, rather a very good concept, but yes, you should learn this. For example, if I have cis alkene, Br2 in CCl4 getting added. Okay, sir. Sir, anti-addition in cis alkene. Sir, anti-addition in cis alkene product will be racemic mixture. But when? Once you have a compound which is having symmetrical structure. Symmetrical structure as in bromine. Okay, sir. What is number of carbon, sir? 1, 2, 3, 4. Sir, because it is symmetrical, so you can number from here also. And because it is symmetrical, you can see there is presence of element of symmetry. Can you see that element of symmetry? Yes, sir. But yes, sir, it will be element of symmetry once they will be on same side. So that is what I'm saying. Product will be optically inactive. But optically inactive due to what? Mesoform or 50% this and 50% other. This is not mesoform, but product was optically inactive. Why? Because in case of cis, racemic mixture is formed. That means 50% this will be formed and 50% its isomer, enantiomer will be formed. Therefore, overall product is optically inactive again due to formation of racemic mixture. Rather, if you have a transalkene, anti-addition will create an optically inactive product, but this optical inactivity will be because of mesoform. I hope everybody get it. Guys, I hope everybody get it. Yes, Dubeji, perfect. Huh. No worries, guys. No worries. Yes, I can see people not allowing the serious students. No, exotic and yes, beta. Exotic and everybody, beta. Chalo. I hope everybody is with me on this. Now, let us move forward. Let us move forward. Chalo. 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 Let us take 5 minutes break, beta. Let us take 5 minutes break. By the time I will just have people removed. So let us take a 5 minutes break. Let us take a 5 minutes break. Okay? Chalo. Yes, guys, I'm back. Come on. So, chalo, we got break also. So that's good, in fact. Yes, guys. So, ready? Let's start again. Chalo, start karo. Perfect, Neha. Perfect. Superstar. Superstar is always there. Now, come on. Yes, come on. Dubeji, perfect. Arthur, perfect. Chalo, let's start, beta. Now, 96. Neha, it's okay. Whoever is here, ultimately, we are here for our own benefit. So let us try and understand and things keep things with us for us, because obviously out of those 25 lakhs, everybody is not serious, and that's why not everybody is going to a GMC. I hope everybody is clear. Cool. Now, sir, let us start again, sir. I mean, continue. Why start again? Let us continue now, sir. If we have these alkenes, then these alkenes can even react not by addition reaction, sir. Sometimes they can even show substitution reaction. Now technically, why? Think about this conceptually as per the general organic chemistry, sir. As per general organic chemistry, why I am saying sometimes substitution can take place, sir. If you have an allylic carbon, then, sir, the carbon next to a double bonded carbon, if attains a free radical, then, sir, this will be resonance stabilized. Then, sir, if how can you prepare that free radical, sir? Beta by homolytic fission. Sir, homolytic fission is favored at what? Beta homolytic fission is favored at high temperature or in presence of sunlight. What reactant we use? We use N-bromosuccinamide. This undergoes homolytic fission, will remove one hydrogen, and this carbon and bromine radical undergoes chain termination, and therefore you get a allylic substituted product. And similarly, chlorination and bromination also at elevated temperature or in presence of sunlight with an alkene will not give you addition product, will not give you vicinal dihalides. Rather, they will be giving you substituted halides, which is allylic halide. Why? Because I hope now you know the mechanism also. Okay, sir. Moving forward. Let me have this child. So now, moving forward. Now, once I was dealing with that mechanism, why did I say after the attack of electrophile, if there is availability of some minus? If there is no availability, then who will attack Br minus? Let's say if I'm using bromine in water, sir, then Br plus will definitely attack. So Br plus attack the cyclic bromine minus formed. But now, sir, instead of Br minus, sir, water can also attack. And if water will attack, or rather OH minus will attack at this carbon, now you tell me where this OH will attack, sir. Sir, there is no formation of carbocation, sir. There is cyclic brominium cation. But the partial positivity you can check. Sir, this has a partial positivity as a 1 degree. So this has a partial positivity as a 2 degree partially positive carbocation. Although I'm not saying there is formation of carbocation, because we have seen no rearrangement taking place. That's why theoretically we have justified this as not complete carbocation, but sir, partial positivity will be stable here, and therefore this will be attacked by this negatively charged OH minus, because now in presence of Br2, not in CCl4, in presence of water, I have Br plus and OH minus as my positive and negatively charged species. So first step is of Br plus, but second is of this that will be producing halohydrin. This is called a halohydrin, as in halogen substituted alcohol, a very important reaction. Now, rather, this you obviously know. If you have Br2 in CCl4, then definitely you will form your fissional dihalide. Moving forward, sir. Now, Yes, so you should also know the concept of Markovnikov addition, and what is this? Negative part of attacking species goes to that double bonded carbon which has lesser number of hydrogen. Why? Because carbocation will be relatively stable. But again, I'm saying this is a Markovnikov addition because negative part is going to that carbon which is having less number of hydrogen. But beta, don't try to learn it, because once you learn it and apply, 90% of the time it is wrong. So rather, why negative part is going over here? Because either carbocation, not carbocation forming over here, because there is no rearrangement seen in such reactions. So the partial positivity of the carbocation is stable here, so minus will go here. I hope everybody's clear. Chalo, moving forward. Now I hope everybody's clear. Perfect. Moving forward. Now, sir, addition of HX also is famous. So, sir, we have done loads of addition in alkene. So, further addition is addition of HX. Now, once this hydrogen halide is added to an alkene, sir, what happens? Sir, if it is a symmetrical alkene, add H on one, X on another. There is no problem, sir. Problem arises with unsymmetrical alkene. Like over here, where I will add H or X. Sir, now you have already told us Markovnikov addition. Sir, you have already told us this is electron rich. So first H plus will attack. Sir, carbocation will be formed. So slow step. So that means only in Br2, in X2, carbocation is not formed. Yes. Else everywhere it is formed. Yes. That means, sir, else everywhere rearrangement can take place. Double yes. So that means ring expansion, rearrangement. That's why I have taken time in that question. Because if you do that rearrangement and ring expansion question, you do not have to worry about any question, because that has given you the best possible knowledge, best possible practice. That's why I make you practice only one question. Moving forward, master, the carbocation formed, so no rearrangement required. So now X minus will attack. So this becomes Markovnikov addition also, and this is my product. I hope everybody clear. This is your simple basic mechanism of electrophilic addition. Moving forward, sir. So that means opposite thing can also take place. Yes. That will be termed as anti-Marconi. Sir, but why it will happen? That was very probable. Sir, in Hoffman also you have said that less substituted product, but sir, less substituted product was formed because that was obvious. So that means sometimes anti-Marconi or addition can also become obvious when only in case of HBr. Why? We'll just see with the mechanism. Let us approach it step by step. Sir, I have an unsymmetrical alkene. Okay, beta. Sir, HBr attacking, okay beta. But sir, now HBr is not alone. HBr is taken in presence of peroxide and sunlight. Sir, HBr in presence of peroxide, then first of all what happened is, sir, peroxide is O bond O, no one is electronegative, so homolysis can take place easily in presence of sunlight. Sir, radical formed. Once this radical sees HBr, sir, who it will take? Sir, the smallest unit, whose smallest unit? H. So H will be taken, alcohol gone, and I have got Br radical. So bromine is electronegative. Electron deficient also because radical form. Now it will move and it will hit somebody. Whom it will hit? Who is the next possible reactant? Sir, alkene is present in most maximum amount. So bromine radical will hit this alkene. Okay. If bromine will hit, sir, free radical will be formed, sir. Okay. So bromine hitting here will form free radical here. This is 2 degree. Here it will be 1 degree. So why it will hit there? Because intermediate like carbocation is electron deficient, free radical is electron deficient, so this will also be formed. After this, so now again HBr will attack, so H will be gone here, again Br radical formed, and Br radical will move again attack the another alkene, so it will transform all the alkene into one bromopropane. That means now the negative part has attached to that double bonded carbon which has more hydrogen, but now this is also probable, sir, because over there first H plus was attacking. Here first Br radical is attacking. I hope you got your point. So logically here also we are just stabilizing the electron deficient intermediate. But superficially if you watch, this is opposite of Markovnikov. Hence this is called anti-Marconi effect also, or Kharash effect also. I hope everybody is with me. Now sir, first tell me sir, why HBr only? Why not HCl and HI? And why not in fact HF? First of all, HF I have not taken anywhere. Why? Again, bond length very less. It does not break. So not break. How react? Gone, sir. But sir, why not HCl and HI? Because HCl and HI does electrophilic addition, Markovnikov addition. Why not anti-Marconi? Beta, HCl or homolysis, hydrogen bond chlorine bond length is also very strong. Chlorine is is large, but not that large that homolysis of HCl is possible. So I've written that also, that HCl is not broken to form radical. For for heterolysis, H plus and Cl minus ion is formed. But for homolysis, sir, we from periodic table also we know, for HX down the group, acidic nature increases because bond length increases. That means that HF is weakest acid, HCl is a strong acid, but in ionic condition. Once you have polar solvent, sir, here I have no polar solvent, and therefore homolysis of HCl is difficult. Point number one. Therefore HCl is not taken. But sir, HI will easily break, sir. Bond length is very large, sir. It will even break easily than HBr, sir. Then why not HI? Because with HI there is a problem. What is the problem? Sir, I radical is in love with I radical. They, they are formed. But I radical, unlike Br radical, this Br radical is attacking alkene. Sir, I radical will dimerize and iodine will be formed, which will be a solid. So solid precipitated out will shift the equilibrium in that direction. Therefore, I radical forms I2, and hence HI is not used. I hope, very important point beta, for your statement based questions only you should know them. I hope everybody is good. Now, what else, sir? Now, obviously, sir, if you do Markovnikov addition, now you know, sir, and if we use concentrated sulfuric acid, then I have, sir, H plus and HSO4 minus. Sir, sulfuric acid will give H plus and HSO4 minus. Minus will go where? Sir, where you have stable carbocation. If I have water in acidic medium, then H plus and OH minus. So this is simple application of Markovnikov addition. But please remember, don't learn Markovnikov. Why OH minus ion going here? Because 2-degree carbocation more stable. Why bisulfite going here? Because 2-degree carbocation is more stable. So carbocation is formed. First do ring expansion, then do rearrangement. I have done one question to make you understand that. Now, sir, some very important reactions of alkene, sir. Sir, oxidation of alkene. Alkene can be oxidized by a mild oxidizing agent, which is called Bayer's reagent, which is nothing but KMnO4, but in cold, aqueous and aqueous condition. That means Bayer's reagent is very limited. So in limited condition, oxidation of only weak bond will be done. Sir, among sigma and pi, what is the weakest bond? Pi bond. So only pi bond will break and OH is formed. Sir, this forms a vicinal diol. But sir, because KMnO4 is a dark colored solution, therefore, sir, that will also decolorize. So just like bromine water, this is also a test of unsaturation. Now, sir, then comes ozonolysis, very famous. How to predict the product? Just see the double bond, break the double bond, add double bond O on both the sides. The product that you have formed are definitely carbonyl compounds. So this is also preparation of aldehydes and ketones. What ozonolysis this is? This is reductive ozonolysis. What is the reagent? First you react with ozone, forms an ozonide, and after that, for removing oxygen, which is reduction, you use zinc in water. If you only use water, that will be oxidative ozonolysis. Sir, what oxidative ozonolysis will do? Reductive you have already seen. Oxidative ozonolysis will just transform the H also in OH, because oxidative ozonolysis is like a strong oxidizing agent. Now I will not leave you. This is your carbonyl carbon. I am having interest in this. So whatever types of C bond H you have, the the action of an oxidizing agent is to break the C bond H into OH. Oxidizing agent cannot break C bond C, but it can break C bond H to OH. So because you have one C bond H left, so I'll transform that into OH. Because you have no, so I'll not transform you. So this is the difference between oxidative and reductive ozonolysis. I hope everybody is there with me, guys. Guys. Again need confirmation, again need confidence from, again need motivation from each and every one of you, whoever is listening, whoever is properly listening. Yes. Yes, Gaurav, perfect. Okay, perfect. Yash Raj Purohit is here. Okay, and then we have Saharika, then we have Zian, then we have Arthur. Ore Bapre, we have loads of students. Okay, good. And then we have Casper, Neha is okay. Neha, perfect. हाँ चलो बेटा. I have loads of serious students over here. So thank you beta. Hasini, Hanshika, Henry. Okay, Henry. Hello beta. You're back. Perfect. Perfect guys. You completely go. Okay, perfect beta. Chalo. Let's start. I mean, let's continue because you are here. I'm happy. Whatever work I have done for you, it is worth it. Good beta. Let's start. I mean, let's. Arey yaar, why I'm saying start. Let's continue, bhai. Come on. Now, sir, what else? This you know, sir. Then oxidative ozonolysis. If you know, then you know the action of strong oxidizing agent also. Oxidative ozonolysis, strong oxidizing agent is same. What are the strong oxidizing agent? KMNO4 in any medium, acidic, basic. Yes. K2Cr27. This is your D block logic. It only acts as an oxidizing agent in acidic medium. I hope everybody know this now. Perfect. Perfect. Now moving forward, sir. Now, sir, some revision. What revision? Sir, alkene you have told us with Bayer reagent, vicinal diol, sir. With, oh, acha, this is the same slide. I beg your pardon. Now, sir, next. Beta alkene, although polymers chapter has been removed from your syllabus, but still they ask a bit of it because this is reaction of alkene. Sir, alkene at specific temperature and pressure can undergo polymerization. So ethene can form polyethene. Propene can form polypropene. Yes, definitely. Those catalysts were very important. Temperature, pressure were very important, but not now important because polymers chapter has been removed. Yes, for JE Advanced, we have to learn this. But yes, for NEET, you can definitely, just knowing this is more than sufficient. Moving forward, sir. A quick question, but I guess, are you able to see the options, beta? Because I guess this is very light. Chalo. Then, rather, let me directly tell you what the question is because I guess that is very light. So let us work on the question problem quite quick. So this is an alkene. Just one question because I have not. We have done an example for rearrangement and ring expansion. Let us do one more. Sir, alkene H plus. Okay. The carbocation here also. Here also. You tell me what will be stable. Sir, there because it will be having more hyperconjugated hydrogens. Okay. So but this carbon is next to a 5-membered ring. Yes sir. So first think of ring expansion, sir. So beta, this bond will break and plus will come here. So that is ring expansion transformed into a 6-membered ring, clearly writing that 6-member ring like this. Now look at the carbocation, sir. Carbocation is here. Can you rearrange after ring expansion? Do rearrangement just once. After ring expansion, rearrangement. So after ring expansion, sir, here rearrangement will not help, but there it will help, sir. But sir, there you do not have any hydrogen, sir. So don't worry. Move complete methyl group. So this complete methyl group will come here. Positivity will come here, sir. We have got this much. We have got. I guess there is a error, beta. Let me, because there should be hydrogen. No? This methyl group is going. So because this methyl group is going, so methyl group will reach here and positivity will come here. I hope everybody is clear with this. Now, if I have reached here, now sir, Cl minus will go and I will have this as my electrophilic addition product because here this is not elimination. That example we have done for elimination because they're first H plus and then the conjugate base. But here I have HX. So first H plus and then X minus. But after H plus, the ring expansion and rearrangement will be preferred and after that you form your product. Obviously, I have a methyl group also over here. So that is not written. I hope everybody is clear now. Guys, perfect. Perfect. Now, Hasini is asking about the duration. Beta, it'll extend. So make sure if you are exhaust, then have a coffee or something because with today's session, I wish to at least complete till carbonyl compounds. So I wish to complete till carbonyl compounds, which will I take. Yes, after this, you can obviously feel it will take less time. Why? Sir, because initially we knew nothing. Now, sir, we have formed aldehydes also, ketones also, carboxylic acids also, some time reactions. So after that, organic, obviously the reactions becomes less in number. So but yes, it will definitely take another 2 hours beta. So make sure you are having that confidence in you, so that you can transform this life journeys in order to revise all the famous organic reactions beta. I am giving you everything for organic chemistry, है ना? Sir, but no questions you are giving? Beta, Tuesday we'll be meeting again. Then we'll be practicing the complete relevant questions, not of organic, but physical, inorganic, complete. Because Tuesday we'll be having an extended session. Because obviously then you'll be having a paper. है ना? Chalo, perfect. Now, what after this, sir? Sir, then, sir, alkene is also finished. Sir, after alkene and hydrocarbon, what we have? Beta, after alkene in hydrocarbon, you have alkynes. So from here, we are starting alkynes. From here, we are starting alkynes. So what about alkynes, sir? What about alkynes, sir? So beta, for alkynes, the first thing, sir, like all organic compounds, sir, first we will read about preparations. There are very limited number of preparation of alkynes. The first one is from calcium carbide, very famous reaction. The limestone is calcium carbonate. One, it is heated, it forms quick lime, which is calcium oxide. Quick lime, when combined with coke, carbon content is increasing. So I formed an increased carbon content compound which is called CaC2 calcium carbide. Calcium carbide has calcium cation and C triple bond C with 2 minus, as in this alkyne as anion. So post hydrolysis, calcium will get OH minus and this C triple bond C will get H and alkyne. Specifically what alkyne, sir? Acetylene gas is produced. Perfect, sir. Sir, alkyne can also be produced just like elimination of alkyl halide we have done, sir. Sir, but one HX will form alkene, so use with dihalides. So if you use vicinal or either geminal dihalide, first you react with alcoholic KOH. One HX removed, sir, but we know this from periodic table only, that if we remove one electron, then the second time if we do, sir, the successive ionization enthalpies increases. Therefore, if you have removed one HX, the second time you need an even stronger base. Who is that even stronger base? Sir, here donor atom was RO minus. Sir, in sodamide, which is NaNH2, donor atom is N minus. Sir, O minus is electronegative, nitrogen is less electronegative, so this is even a stronger base. So a stronger base can again attack you and again make you remove those another molecule of HX, and that's why you get an alkyne. I hope everybody's clear. Now, some extra methods, because yes, for alkyne NCERT throws only these reactions with you, but yes, for alkyne you should know at least few extra reactions. The first one is again a direct friendship with alkyl halide. Chloroform, which is CCl4, reacts with silver metal, and the chloroform molecule, both the molecules, they transform into specifically acetylene. Point number one. Sir, once you use a tetrabromo derivative, then zinc in alcoholic medium, mild acid like ethanol, can also transform the bromine and forms alkyne. Important reaction. And last but not the least is your common sense, which we have already seen, sir. So the electrolysis, sir. So if you use a dicarboxylic acid, but that dicarboxylic acid is already having an alkene, then sir, this CO2 decarboxylation will be done and radical will be produced. So if alkene can be produced, sir, then alkyne can also be produced. So this is just common sense of the mechanism of coal-based electrolysis that we have seen. Okay, sir. Moving forward. Now coming to, sir, this is becoming very easy, sir. Alkene, we took so much time for the preparation. Sir, alkyne done. Yes, this is what I'm saying, that after this, the content will become precise. Now, that's why, beta, you must be thinking in your head that class 11th had only one chapter of organic. I mean, the concept, obviously the GOC is there, but hydrocarbon is not just one chapter, beta. Hydrocarbon is actually the foundation of complete class 12th. So that's why even I wanted to give you all the reactions of hydrocarbons, because hydrocarbons will enable you to do anything. Hydrocarbon will enable to you to learn anything and everything for your examination. है ना? चलो, perfect. Now, sir, chemical reactions of alkynes. What are these chemical reactions of alkyne? First one is, sir, electrophilic addition. Sir, same like alkene? Yes. Sir, because alkene has one pi cloud, they have two pi cloud. So they are in fact more electron rich, sir. So they can have more affinity towards electrophile. So same reaction will happen? Yes, sir. So let's say first I'll do hydrogen, although these reactions are not perfect. After this, it is an example of electrophilic addition. So these are some basic addition reactions. So hydrogenation can form alkane or partial can form alkene. Remember Lindlar's catalyst and Birch reduction. Now, the X2 can form vicinal dihalide, but here I have two pi bonds, so it will be not dihalide but rather tetrahalides. Now, sir, Markovnikov addition of HX. So first H plus will go, then X minus, sir, where minus will go. Sir, here the partial positivity will be more stable. So first add first HX, you get a vinylic halide. Then after that, again add H plus, sir, but think conceptually, okay, beta. So where H plus will go, here H plus will go. Why? Because this carbocation is not now is inductive stabilized. Sir, the lone pair of halogen will make that carbocation resonance stabilized. I hope you're getting it. So that means, sir, this is resonance stabilization. So therefore, again, this carbocation will be formed, and therefore, what dihalide you are going to produce, sir, always it will be a geminal dihalide. What is a geminal dihalide? Once the halogen is attaching on the same carbon. I hope everybody is with me on this. I hope everybody is with me on this. Chalo, perfect. Now, perfect. Okay. Chalo, perfect. Now, sir, some more examples. Beta, just do the same things. But, sir, hydration is done using water, and in order to create the catalyst which should initiate the reaction, we add few drops of H2SO4 or HgSO4. Rather, sometimes the complete thing is not written. They even simply write H plus or Hg2 plus. So what does they do? They again initiate the reaction first. H plus attacks, then carbocation. Where it will be formed, sir? Here only. Then first OH, sir. But now, sir, you do not need the second molecule. Why, sir? Because this is, sir, that was vinylic halide. Vinylic halide is unstable, so I need another HX. Sir, this is a enol form. You remember keto-enol isomerism? So this is double bonded carbon having OH. So this is an enol form, generally less stable. So in order to stabilize, it will tautomerize. Hydrogen will go here, double bond will come here. So you get your corresponding carbonyl compound. Obviously, technically it will be a keto form, but yes, sometimes aldehyde can also be formed if you have limited carbons. Now, sir, if you have alkyne, then sir, polymerization here also can happen like alkene. So at specific temperature and pressure, you can have linear polymerization, but this is rather very famous, and that's because it is very famous. So I'm giving you catalyst also. If you pass acetylene to a red hot iron tube, so ultimately you need just a tube. Which tube? Iron tube. But it should be heated till what temperature? Till 600 degrees Celsius, so that the iron turns red. And during that time, cyclic polymerization take place, because we know six-membered ring is free from any type of strain. And once radicals are formed in these carbon, they transform and do the chain termination. And therefore, alternate pi cloud forms your benzene. So this becomes a preparation of benzene also, which is a reaction of alkynes. Now, sir, but apart from alkenes, no, terminal alkynes have one more reaction. Sir, we know sp hybridized carbon is electronegative, and that's why if this terminal sp hybridized carbon has hydrogen, then it can give some acidic reactions also. I am not saying it is very strong acid, but yes, some acidic reaction. Very strong acid as in it is not stronger than water. That's why it will not react with base. But sir, it can react with those components with which it is stronger acid. Like for example, even if you are a weakest acid like alcohol, it can react with sodium metal, because metal is very reactive. Some metal plus acid forms salt. What will be the salt? Sir, it will be sodium alkynide, because that is propine, so it is propionide with hydrogen gas released. The sodamide, so if with sodamide also it can release H plus because this NH2 minus will take that H plus and ammonia gas will be released and again you have formed a salt. Sir, because you have acidic hydrogen, so this acidic hydrogen can even react with Tollens reagent because that acidic hydrogen can again form ammonia because this Tollens reagent also has ammonia as a ligand, and that ligand ammonia can react with hydrogen and ammonia gas releases and it forms a salt. So that means, sir, alkyne also give Tollens test, yes, but it silver mirror it is not formed because Tollens reagent is technically an oxidizing agent. It is not oxidizing, it is acid base reaction because it is forming a salt. And this, but sir, then how it is a test? Because you can see, sir, you said silver mirror does not happen. Beta, you can see some color change. What is that color change? The silver salt is a white PPT. So technically, if you use Tollens reagent with terminal alkynes, you can see some physical change. What is that physical change? White PPT. So is it said, can you say this, that terminal alkynes respond to Tollens reagent? Yes. Terminal alkyne give Tollens test, wrong, because with Tollens test we have a reference that you should form silver mirror, so they do not form silver mirror, but they can be identified with Tollens reagent because they form white PPT. A very important point. Sir, take my name, Huzair. So Huzair, what is it? You have doubt? Really sorry. Okay. Arey, chalo. Doubt? Anybody? I hope everybody is clear. Chalo. Perfect. Perfecto. Moving forward. Now, sir, sir, move forward. हाँ बेटा, moving forward. चलो. Ah, चलो, moving forward. No, actually, this is the reason I have done this because चलो. Perfect. हाँ, white PPT ने हाँ, yes. Now, next is preparation of benzene. Sir, alkane finish, yes. Sir, alkene finishes. Sir, alkyne took very less time. It will be taking very less time. So let's start. Next is obviously I do not have to write now because I have a heading also that I have preparation of benzene with me now, sir. So then for benzene also we'll do the same. Yes, first is preparation, second is chemical reactions. Now for benzene, let us do it. What is benzene, sir? If you take benzene, then first you should know preparation. Sir, some preparation we have seen, so I'll not be repeating them. But yes, sir, cyclic polymerization of acetylene, sir, we have seen. Reduction of phenol, sir, again a reaction of phenol. That means beta, if phenol reacts with zinc as a metal, this zinc metal will abstract that oxygen and form zinc oxide, and ultimately you form benzene, a very important NCERT reaction. Similarly, sir, soda lime decarboxylation, yes, because free radical do not even care whether you have partial double bond character, so here also CO2 will be released, sir, leaving a radical over here. So this radical and this H will form, or rather, because we have seen this mechanism, this was a minus and that H plus, they will form benzene. So soda lime decarboxylation will also result in the formation of benzene, famous reactions. Now, sir, this is biphenyl and this is alkyl benzene. So these are some substituted benzenes that you form with Fittig and Woods Fittig. So already done, but still I guess this came. Now, coming to chemical reactions. Sir, just like alkene, benzene is also, sir, it is surrounded by pi electron cloud. So now you tell me who can approach this benzene? Sir, this is electron rich, so only plus will approach. So what is plus? Electrophile. And this electrophile once add will disturb the aromaticity. Sir, the extreme case of stability of resonance is aromatization, which is the three definitions that is followed as per Huckel's rule. So you should be cyclic so that the pi cloud can be perpendicular to each other and they can delocalize. Second point, you should have complete current cycle of these pi electron clouds. And third is you should have how much of pi electrons? 4n plus 2 pi electrons. So this is your Huckel's rule. Every compound that follows Huckel's rule is called aromatic. Benzene definitely follows Huckel's rule and is aromatic. But sir, if electrophile will attack, then aromaticity will be gone, sir? No. Why it will not be gone? Because electrophile comes and substitutes hydrogen, so aromaticity is remained. So that means benzene forms C6H5 and an electrophile is introduced. Now, Sir, how many are the reagents that can do this? Very famous. Sulfonation, the reagent is oleum. Oleum is H2SO4 and SO3. Nitration, concentrated HNO3 and H2SO4. Chlorination, again Cl2 or Br2 in presence of any Lewis acid as in which can take electron and force X2 to form as X plus and X minus. So either iron or FeCl3 acts as a Lewis acid. Sometimes dark is written. Why? Because in sunlight this will not take place, something else will take place. What, sir? Obviously addition reaction. Why? We'll see. Now that's why with them sometimes dark is written. Why? We'll see in example. Similarly, bromination, catalyst will be Fe or FeBr3. They will act as a Lewis acid. They will force X2 to form X plus and X minus. Now, so Friedel-Crafts reactions, Friedel-Crafts alkylation will use alkyl chloride. Friedel-Crafts acylation will use acid chloride. Again, Lewis acid over here will be anhydrous AlCl3. What they will do, they will form an electrophile. Sir, alkyl benzene, sir, alkyl phenyl ketone, sir, benzene sulfonic acid, sir, nitrobenzene, sir, chloro or bromobenzene. Very famous reaction. Now, why I'm moving from them? Because I'm very much interested with mechanism. First is what are the electrophiles? In sulfonation beta, electrophile is not any charged species. Electrophile is SO3. You can obviously see the inorganic reaction happening over here, but you have to please keep in your mind electrophile in case of sulfonation is not charged, it is neutral SO3 molecule. Then sir, why SO3 is attacking? Because look at the oxidation state of sulfur, it is +6. Beta, +6 oxidation state is the highest. Sulfur is surrounded by 3 electronegative oxygens, and sir, the shape of sulfur will be trigonal planar, so it is, the sulfur is exposed also from this side also and this side also. So that means, sir, this SO3 acts as an electrophile, a very important point. Next, sir, in nitration, HNO3 and H2SO4, sir, H2SO4 is a strong acid, will give H plus. It will be forced to give OH minus. So, sir, NO2 plus and bisulfate ion. Sir, benzene is electron rich. So, who will be attracted? Sir, on NO2 plus. Only one plus you have. This is minus. Sir, not required because minus will repel. So, this will be my electrophile. I hope so NO2 plus generated. Now, sir, halogenation, I already told you, you need a Lewis acid, and Friedel-Crafts alkylation and acylation, you need a Lewis acid. The halogen will go carbocation, which is acyl carbocation, this is alkyl carbocation, this is X plus electrophile. So these are the electrophiles. Now, what happens? First, these electrophiles are formed, and they are, let's say this is a pi cloud, it has substituted. E has just been introduced, forming a carbocation. So you will say why it is happening, aromaticity is getting disturbed. Just for fraction of seconds, and that too for fraction of seconds, the carbocation that is formed, yes, it is not aromatic, but it is not a beggar. It is not any carbocation. It is a extended resonance stabilized carbocation. Yes, definitely not aromatic stabilized, but still very much extended resonance stabilization. And this is called rhenium ion, where this plus is shared within all these 5 carbon. Only this 6 carbon is not sharing. That's why the aromaticity is not there, but still it has extended resonance stabilization, where resonance is extending from this carbon till this carbon. Still, I'm not saying it is formed. It is formed for fraction of seconds. Why, sir? Because in the next second, whatever minus, whatever after, whatever in the reagent, whatever negatively electron rich species will be present, that will act as a base, will give the electron to the same carbon on which electrophile has attached, and the electron of hydrogen will be transferred to this carbon. Although this carbocation was very stable, but within a fraction of seconds, it will be transformed into an aromatic stabilized substituted benzene. I hope everybody is clear. Very great and very beautiful mechanism, beta. Now, moving forward. Sir, now we know preparation of benzene also. Now what else? Beta, for reactions of benzene also that you have started knowing, you should know if you have substituted benzenes. Then sir, these substitutions can be of how many types? Beta, these can be basically of 2 types. either there may be some groups attached to the benzene ring which will be transferring their electron cloud. What electron cloud, beta? Through resonance, non-sigma electron can come into a ring, or non-sigma electron can be taken from the ring. That means resonance effect will be applied. So if there is a group which is having lone pair and having no empty orbital, then those lone pair will come in conjugation with the ring and they will be a plus R group. Sir, because of a plus R group, electron density will be increasing where, sir? At ortho and para position. So electrophile will be forced to come at ortho and para position, and electrophile will be loving to attack this ring. Why? Because this ring is further increased with electron density, and therefore these groups are called activating groups. Now, what does this activating group mean? Obviously this CH3 will also act as an activating group, because CH3 will apply plus hyperconjugation. It is not having lone pair, it is having lone pair, so this is a plus R group. That is a plus hyperconjugating group. But both are activating group, as in they are increasing electron density in benzene ring and increasing where directive influences at ortho and para position. Now, if you compare this with alcohol, then alcohol OH is also an activating group, sir. But what is the basic difference that you can only understand through the reactions? This is an activating group. Phenol is also activating group. But once we have seen reaction of phenol, if this was used with concentrated HNO3 and concentrated sulfuric acid, that means I was forcing electrophile to be produced. If I use even dilute HNO3 with phenol, I do not even need H2SO4. I do not even need strong concentrated HNO3. Why? Because this is so activating. The minus here is so strongly is located at ortho and para position that HNO3 will have self ionization. It will love, NO2 plus will love to go at ortho and para position, which signifies that phenol is not activating. It is super strong activating group, and therefore even dilute HNO3 creates ortho and para isomer. Okay. In general, which isomer is more stable? Sir, para, because less steric hindrance. But in case of ortho nitro and para nitrophenol, we say that mixture of product is produced. Why? Because ortho is not less, it is also comparable. I'm not saying it is more, it is comparable. Why? Because of intramolecular hydrogen bonding. And similarly, if I use concentrated, I do not even need H2SO4 here. In order to create NO2 plus as electrophile, H2SO4 is required with HNO3. With phenol, you do not even require H2SO4. If you take dilute, it will happen. If you take concentrated, then excessive nitration take place. In all the positions of ortho and para position, you will have substituted NO2, and this is nothing but 2,4,6-trinitrophenol, which is nothing but it is also known as picric acid, a very famous compound. I hope everybody know this. Chalo, perfect. Now, after this, sir, next directive influence. What is the next directive influence? The next directive influence is, sir, if you have a group which is rather deactivating. Now, what does this mean? If the benzene ring or this benzene conjugate system is connected to an atom which is having empty orbital. Sir, but carbon is not having empty orbital. Think about it. If this pi bond moves here, then this carbon will have an empty 2p unhybridized orbital. Sir, if I have empty orbital, that means I'm electron deficient, and now I will attract the electron density. So that means a carbonyl group will always be minus R group. So this carbonyl connected with anything, H, R or whatsoever. So all these derivatives will be nothing but they will be applying minus R. Resonance is always operational at ortho and para position. So this will also be operational at ortho and para position, but because of removal of electron, I will get a positivity. But still, sir, you have shown us that photo that ultimately benzene is electron rich. Yes, maximum electron cloud has been withdrawn. So electrophile will not be happy to attack. But sir, that's why we have seen that first step, that we are forcefully creating the electrophile. So if at all an electrophile is created, first of all, like phenol, Even if you do not use H2SO4, NO2 plus was created. Now NO2 plus will never be created. You have to forcefully create it. So once electrophile is created, then it will attack. It is not feeling happy. So that's why this sad symbol, that electrophile is not happy. But if it is generated, then where it will go? Sir, this is plus, this is plus. So preferably where you have electron density at meta position. So you get a meta substituted product. And that's why we say generally the groups applying minus R effect are deactivating and they are meta directing. Now, next point is a question, a true false question. All deactivating groups are meta directing false. Why? If you just look at halogens, then yes, because chlorine, bromine and iodine, not fluorine. Chlorine, bromine and iodine has weaker resonance. Why weaker resonance, sir? Because chlorine will form this pi bond with 3p orbitals of chlorine. Bromine will form with 4p, iodine with 5p. So sir, if pi bond is formed between dissimilar energized orbitals, then that pi is not strong. And what is their resonance effect? Sir, I only have lone pair, and lone pair can go inside, so they can be plus R. But sir, because they have empty orbital, sir, chlorine, bromine, iodine, everybody has empty orbital, so sir, they can take also, so they are both plus R and minus R. Point number one. Sir, they are highly electronegative also, so they are definitely minus I. Plus their resonance is very weak, sir, because they are, the pi bond is formed between dissimilar energized orbital. Technically resonance is strong because all the time we speak of resonance, we talk of second period elements. So here they are not second period elements, and hence resonance is weak. And what is their inductive nature? So inductive is definitely minus I. So ultimately they all are electron withdrawing groups, deactivating group. That means here also electrophile is not interested, but yes, if at all it is created, it will attack. But attack where? Not at meta. Why? Because ultimately their resonance is plus R. Ultimately their resonance is plus R. So electron density, yes, this electron density will not be very much, but if at all electrophile is formed, why it was going at meta? Because at orthopara there was plus. Here there is no plus, but it is deactivating because its minus I is strong. So where this electrophile we go? Sir, again, directive influence is decided by resonance only. Although this electrophile is not feeling activated, it is deactivating group. But if at all it is formed, it will go at ortho and para position, where para will be the major product, because here there is no case of hydrogen bonding like phenol. Now, if you do this electrophilic substitutions n number of time, like if you are using chlorine in excess, then you get this, which is 6 hydrogen substituted C6Cl6, also called perchlorobenzene, hexachlorobenzene or perchlorobenzene. General name is perchlorobenzene. Now, so these are some, sir, that means, sir, with this we can learn aryl halides also. So sir, you have told us that this is orthopara directing and deactivating also. So if I'm forcefully creating electrophile, where it will go? Orthopara, major will be para, 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 orthopara, those all reactions, beta, they will make one reactions for you. I hope everybody is with me moving forward. Now, sir, you said you have written dark, and you said you will tell sunlight. This is sunlight, beta. Actually, what happens is, again, we know homolysis do not even care whether you are single bonded, partially double, whosoever you are. If sunlight or high temperature is there, they will break all the bonds, and hence even the aromaticity of benzene is destroyed in sunlight. So if I take chlorine in presence of sunlight or at high temperature, instead of substitution, addition happens. So I have hydrogen also here. So that means this is C6H6Cl6. Nowhere it is benzene, but still generally it is called benzene hexachloride, also termed as lindane. Yes, some of its conformers, not conformers, geometrical isomers, but yes, that is advanced topic, so leave. And also called gemexane. Why? Because it is industrially it is a powerful insecticide. I hope everybody is clear now. So that means you have told us one thing, that aromaticity of benzene can be broken. NCERT also tells you this thing. Now, extra thing that I'm telling you, even you can do hydrogenation of benzene at elevated temperature. catalytic hydrogenation. And this is very famous. You can do Birch reduction also, but Birch reduction of benzene will give you a kinetically stable product where you will be having 1 2 3 4 5 as in cyclohex 1 comma 4 diene. So that's not a conjugated alkene, mind you. Yes, it is a kinetically, because benzene is a thermodynamically stable product. This becomes a kinetically stable product, a very beautiful mechanism, but yes, valid for advanced, not valid for you. So sodium in presence of ammonia or alcohol is called Birch reduction. This can transform this benzene into a kinetically stable diene. That diene is not conjugated. I hope everybody is with me on this. Chalo. Moving forward, that means, sir, how complete hydrocarbons gone, sir. Complete hydrocarbons done, and now, sir, organic will become very precise for us, very small for us. Now let us start to begin class 12th and begin and finish also, because it will be taking very less time. But yes, so with this we are going to start alkyl and aryl halides, which will be very easy for us to do. But yes, even now I feel this is 11:35. Okay, so let us take a good 10 minutes break and then we can again start. है ना? Good 10 minutes break, everybody. Guys, good 10 minutes break. Chalo. But I want everybody to come back. So let us take a good 10 minutes break. I will be good 10 minutes break. So this is 11:35. So I will be back by 11:45 p.m. But beta, yes, make sure you come back. Why? Because beta, with this day, I mean, I will just be taking extra maximum 1 hour, maximum 1.5 hours, max. But yes, I will make you revise all your class 12th organic also with this. Good? Chalo. So with this, let us move to the break. I will be just back. है ना? Hello. Yes, guys. So, welcome back. I hope everybody had their share of break and I am visible and audible to everyone. Just give a confirmation, guys. Chalo. Perfect. Ravi Chandra. Yes, beta. Tell me. You're saying, sir, sir. Duration. Beta, as I already communicated, what we'll be doing is, what we'll be doing is, we are already starting with alkyl and aryl halides. Then we'll be moving to alcohol, phenol, and ether. Then we'll be moving to aldehyde ketones and carboxylic acid. And yes, I guess after carbonyl compounds, aldehyde ketone and carboxylic acid, we have let us practice the chapter of amines and biomolecules with questions only. Why? Because with amines and biomolecules, sir, the reaction per se becomes irrelevant, right? Why? Because, sir, for them the questions, the relevant questions are more than sufficient. So for them we'll definitely be, as I already communicated, that for them also and for all the other chapter revision, we will be having an extended session on Tuesday where we'll be practicing and revising the complete chemistry but with questions. Good, guys? Chalo. Perfect. Everybody, perfect. Now, let's start beta. Let's start this process again. Let's start this process again. And the way we are going to do this process is, sir, alkyl halide, alcohol, phenol, ether. So, just beta 1 hour, maybe 1 hour, 30 minutes. I don't think it will take much more than that. है ना? Chalo. So, I hope everybody is again ready to start the aryl halides, the alkyl and aryl halides. Sir, what about alkyl and aryl halides? Sir, so first of all, the SN reactions. Why, sir, directly SN reactions? Because we have just came across the reactions of aromatic, the benzene and the substituted benzene. Sir, isn't it a substituted benzene? So if you have a substituted benzene, then do some more reactions for substituted benzene. That will make a relationship also, a relatability also. Okay. So what are you talking about? Beta, I am talking about that this lone pair is definitely in conjugation, sir. You have already told us. Yes, less, but still it is having a partial double bond character, and because of this nucleophile cannot attack, sir, because partial double bond will not break. But sir, if we try to forcefully make this reaction happen, then can we do it? Yes. In fact, it is an industrial process named after Dawes, and Dawes process says at an elevated temperature of 350 degrees Celsius, at extremely high pressure of 300 times of atmospheric pressure, you can definitely make this OH minus attack and substitute that chlorine. But sir, phenol is a strong acid than water, and in presence of base, you can't make phenol exist. Why? Because the neutralization will take place, so you'll form a salt. The salt will be sodium phenoxide, and once you do acidification, then you get your phenol. I hope this much everybody is clear now. Yes. Now you can simply write the reaction also, that this is through from halobenzene you can form the corresponding aromatic alcohol. This is Dawes process. But sir, because of this, we are understanding, because of resonance effect, that if this aryl halide is substituted by electron withdrawing groups, that too excessive of electron withdrawing groups, then if those electron withdrawing groups are connected at ortho and para position, so they will increase delta positivity, sir, because minus R group will apply resonance effect and positivity will be coming at ortho and para position. So if electron withdrawing group is attached at ortho and para position with respect to halogen, so this delta positivity is going to increase. And if it is going to increase, then this OH minus ion will not be that difficult. It will not be feeling that much of resistance, and rather it will be feeling motivated to attack this particular carbon. That's why we say electron withdrawing group at ortho and para position activates the ring. Sir, how come it is activating? Let us see with the NCERT examples. Why it is? Acha, I have switched it off. That is what I'm thinking. Why it is not moving forward? Ha, sir, now let us see the experimental results also. Sir, you said that if you add electron withdrawing group, then just look in the previous one. There I have used 300 times of atmospheric pressure, and I do not need to increase the pressure also. I was doing that reaction at 350 degrees Celsius. Now it is happening practically at half. So this means that this OH minus ion is feeling activated to go there and transform the substitution and forms the corresponding aromatic alcohol, which is phenol. Sir, if we add ortho and para position, both, sir, see temperature is even 95 degrees Celsius. And if you introduce them at all the three position beta, you do not even have to use a base. Even water will do this and you will get your beautiful picric acid. So that means these are my reactions of aromatic alcohols of aryl halide, which we have directly derived from the substituted reactions of benzene. Definitely, those were the reactions of essence substitution by a nucleophile. So that they were aromatic nucleophilic substitutions. But sir, nucleophilic substitutions you have not discussed. Let us browse them also. But I hope we have done the more logical chunk using the concept of deactivating and activating group and resonance application of benzene. Now, one more very famous point from the chapter of alkyl and aryl halides is the polyhalides. One of the very famous polyhalide is this DDT, how it is prepared. DDT is nothing but diphenyl. So at para position you have chlorine and this is a chlorophenyl. So I have diphennyl. Then I have trichloro, which is this Cl3 ethane. Now, how it is produced? First, you have chloral. What is chloral? If you have two carbon aldehyde, which is acetaldehyde, you transform all the alpha carbon of that hydrogen with substitute with chlorine. So CCl3CHO becomes your chloral, and this chloral reacts with the para substituted hydrogen of chlorobenzene and removes water. Sir, in order to remove water, you need a dehydrating agent. Who is that dehydrating agent? It is concentrated sulfuric acid, and whatever you produce is your famous DDT. Now, one more important thing, some facts about freons. What are freons? So freons are chlorofluorocarbons. What are their properties? Sir, they are very stable, non-toxic, non-corrosive, and non-reactive and easily liquefiable gases, sir. Sir, they are the most famously, the widely used freon is freon 12. Now this 12 mean that you have C with two fluorines and two chlorine, as in CF2Cl2. Now it is used as a refrigerant and a propellant in all the aerosols or the sprays that you use, and it is responsible. Now obviously now these days it is less used. Why? Because it is responsible for the depletion of ozone layer, because obviously it can have that homolytic fission, and that homolytic fission can transform ozone into oxygen. So it is depleting that ozone layer, which is stopping the ultraviolet radiation or heat of the ultraviolet radiations from the sun to enter the earth atmosphere. And hence you must have seen the although this is not very basic thing, that the temperature of earth is rising. So the use of such freons, they are which are actually the refrigerants. Once they were used as a refrigerant in large quantity in these air conditioning units, but yes, now these days they have been banned. And yes, a good knowledge from NCERT that you should have from chemistry in everyday life. Now, moving forward, sir, then sir, move to aryl halides. You have discussed first, sir, a part of it. Now let us move to alkyl halides, sir. So quickly moving, it will also be acting as reactions of alcohol. Why? Because the very first preparation of alkyl halide is through alcohols. So in alcohol you can substitute this OH and replace halogen. How? Very simple. There are many reagents to do it. I guess I'm missing a slide or what? No, I'm not missing any. Yes, few of the initial reactions I have not written. Why? Sir, because few of the initial reactions we have already seen. Where? in the previous slides. So what are the next reactions that you should know that alcohol can transform to? And that's why I've written 6 over here, and that means there are some few more reactions, but yes, those reactions we have already seen in the previous slides. So directly see to the more important ones. Now the first one is, if you use red phosphorus and X2, technically you can directly use PX3, but rather why I'm saying red phosphorus plus X2, because directly only PCl3 is known to exist in nature. Sir, what about PBr3? At if you use at lesser temperature, even PBr3 you can get, but Pi3 you can never have. Why? Because bond length of P bond I is very small, very large, so it breaks. So but if you want to form PC, sir, but if I form Pi3 in runtime, then obviously you can use it. But how to form Pi3 of any PX3 runtime? By using red phosphorus and X2. This X can be bromine and iodine, so in runtime you can form that Pi3, and with Pi3 you can form alkyl halide, and the byproduct is very important. That's why I'm specially writing this reaction. This byproduct is phosphorus acid. Sir, what about the pentahalide? For pentahalide only PCl5 is known. Now with this PCl5 you can obviously form alkyl halide, which is alkyl chloride precisely, along with POCl3 and HCl. This POCl3 is phosphorus oxychloride. Clear, sir? Now, very famous reactions. The first one is reaction with thionyl chloride, and the second one is thionyl chloride, which is SOCl2, but in presence of pyridine. Now, what is the difference? Both will produce alkyl chloride with the release of SO2 and HCl gas. In fact, this is a very good method because because you have got pure alkyl chloride over here. Whatever were the byproducts have been released as gases, so you get very pure alkyl halide. But there is a problem with the stereochemistry. Sir, what problem with the stereochemistry? Beta, if you just use thionyl chloride, you get a the product which is having same optical activity as the reactant. But sir, for that even reactant has to be optically active. Yes. So if your reactant is optically active, then the product will have the same optical activity. And if your product is reactant is optically active, then your product will be an inverted product if you just use pyridine as a base also along with SOCl2. Now sir, why is this a case? 90% of the time your job will be done if you just know this much. 90% of the time your job will be done if you just know this much. I hope you're getting it. But sir, for few good questions you should know the mechanism also. Now acha, extra points. Acha, I guess I have misplaced a slide. So okay. So the previous reactions were the very first famous. I will be giving the mechanism of these two, but yes, before that some extra points. So it will be coming. I guess I just mixed a slide. So now one of the reaction is, sir, reaction of alcohol with Lucas reagent. Now what is Lucas reagent? It is concentrated HCl in presence of anhydrous ZnCl2. Concentrated HCl in presence of anhydrous ZnCl2. Now what is this Lucas reagent? Sir, common sense is just the same. Sir, you have already told us that C bond O never breaks. So first I need protonation. Now protonation can be done by HCl also and ZnCl2 also. Why you are saying sir any Lewis acid or H plus? Because sir I need protonation, because this C bond will not break once it is protonated by either Lewis acid, which is ZnCl2, or H plus. So this oxygen will be removed in form of water and I will get a carbocation. And now sir, this is very easy, sir. If you form a carbocation, which carbocation is formed easily? Sir, 3 degree. So which alcohol will give this test easily? Sir, 3 degree. In fact, once this reaction is completed, the Cl minus ion attack and forms alkyl chloride, and the physical property of alkyl chloride that whenever it is formed you can see it, because it is visualized as a white turbidity. So that means 3 degree will form white turbidity instantly. Yes. So 2 degree will form white turbidity, but yes, it will take time because 2 degree carbocation is less stable. So technically the fact is it you have to use this Lucas reagent, but yes, you have to heat also for a frame of 5 minutes. Then you get your white turbidity. And obviously, if you're getting white turbidity, but after very long time of somewhere around 35 to 40, 25 to 30 minutes, that too after heating, that definitely means that this is a 1 degree alcohol. And as I've already told, 1 degree alcohol, 1 degree carbocation is not stable. Stop saying this, that 1 degree carbocation is stable. Beta, it is not at all stable. You can obviously assume and feel that because you are taking 30 minutes after heating and then something is formed. So you tell me, is it stable? So definitely you should keep this in mind. 1 degree carbocation is not less stable. It is not formed. But yes, obviously, are are human beings inflammable? No. But even we get fire? No. So the point is only this much, that yes, if you vigorously try to do something, then yes, if you try to heat it for 30 minutes, then you get white turbidity. So this is the reactivity of carbocations. And what about HX, sir? Sir, technically, because it is acting as a test, so I'm precisely used HCl, or else you can use any HX. Out of that, HI will be most favorable because bond length will be broken very easily. Now coming to what I was saying, that SOCl2 and normal thionyl chloride or thionyl chloride with pyridine. If you have only thionyl chloride, then retention of geometry was happening. Now why retention was happening? Because of the fact, sir, obviously alcohol will be protonated because sulfur is in plus 4 oxidation state. Alcohol will be getting attracted. The moment lone pair will attack oxygen, chlorine will be gone. So this is the intermediate that has been produced. The moment intermediate is produced, sir, with respect to this sulfur, shape is trigonal planar. So these lone pair electrons are very much interested in the delta positivity of carbon. They will give their electron and this electron will be gone over here. This sulfur is very much happy because it will be forming SO2 gas, gone, and you have got your alkyl chloride. But sir, this chlorine is not coming from outside. If a nucleophile is coming from outside, then it cannot approach where the already existing species is. That therefore generally backside attack takes place. But sir, here this is happening within the molecule. So because this chlorine is already present within the bonded molecule, therefore this attack takes place from the same side. And the moment it has received electron pair will be moving in order to facilitate the formation of SO2. That means this is a substitution, nucleophilic substitution, which is happening internally. So from the orientation where the leaving group has gone, in the same orientation the attacking species has attached. That's why whatever was my three-dimensional optical stereochemistry, it will remain the same. And that's why retention of geometry take place. Very important point. And sir, if you use pyridine, then beta, this formation is obviously no different. First this is formed, but now internally it will not take place. Why? Because that would have taken time. So this is a very strong base, pyridine, and this pyridine can also give electron. If it gives electron, the moment this intermediate is formed. So the moment this intermediate is formed, because this has given electrons, oxygen has got O minus, and because oxygen has got O minus, so this O minus will again get delocalized. The moment it has got delocalized, this chlorine will be forced to go away. This will be forced to be leave as Cl minus. Now also at this point also this Cl minus is attacking, but it was within the molecule. Here also only this Cl minus is attacking, but this has been removed from the molecule, and now this can only attack in a backside fashion, because here, which is not part of this is also electron rich, this is also electron rich. So this is a point blank and simple SN2 mechanism. And we definitely know, sir, a perfect SN2 mechanism will invert my optical configuration, my three-dimensional optical stereochemistry. So this will rather give, because of this backside attack, an inverted product. So if but many of the students miss this. If my reactant is optically active, only then I can predict whether the optical activity is same or reversed. Otherwise, yes, I'm not saying the orientation will change. It will be attacking from the same side, it will be attacking on the opposite side, although this may not be seen in the optical activity of the product. I hope you get it. This is the mechanism. This is the difference which this base pyridine is making, a very important point. Moving forward. Now, sir, some more preparation of alkyl halides. So some more preparation of alkyl halides. Out of them, the next one is halogen exchange, rather a very famous one. Now, what is this halogen exchange? Generally, you have seen alkyl chlorides and bromides are easily formed. What were lesser seen? Sir, fluorides we haven't seen anywhere. Yes, iodides with red phosphorus and I2 you can make. But sir, if you are forming some alkyl halides very easily, then they will be quite cheap industrially. If you there are some alkyl halides which you are not able to form, then they, if required in market, they will be sold at a higher price because less demand, less availability, so more price. So that's why industrially these reactions were discovered and were named as halogen exchange, where we have used halogens only, but what halogens? Which are very easily produced, like chlorides and bromides. So in order to produce iodide, it is just a rhyme to remember. Finkelstein has I, so it gets formation of alkyl iodides. So Finkelstein I, so iodides. In order to form that iodide, you either use sodium or potassium iodide in presence of acetone, because acetone being a covalent, being a organic solvent, covalent solvent, organic solvent will not allow uh, will organic solvent will allow the precipitation of these halides, because these halides will have more ionic nature, so will be precipitated out of this organic solvent. So with this precipitation, the reaction can also be shifted to forward direction as per Le Chatelier's principle. So a simple application of Fazan's rule, although you should just remember that sodium or potassium iodide in presence of acetone will do halogen exchange of iodide, and if you want fluoride to be formed, then use metallic fluorides with these halogens. Metallic fluorides include silver, arsenic, antimony, cobalt, and mercurous fluoride. Yes, there are other fluorides also, but if you remember just these five, it is more than sufficient. Moving forward now, sir, yes, apart from this, even you can form alkyl halide, which is just alkyl bromide, that too in very high percentage yield with what? With ester. What ester? Sir, silver salt of carboxylic acid. I beg your pardon, not ester. With silver salt of carboxylic acid. If silver salt of carboxylic acid is precisely treated with bromine, but yes, that bromine water, that is an organic solvent of CCl4. You definitely this decarboxylation take place where CO2 is released, silver forms silver bromide, and you get your corresponding alkyl bromide in a very good percentage yield. The mechanism, obviously, we are using silver, so decarboxylation is taking place, so it must be free radical only, so it is written also free radical, but you should just know this reaction because percentage of alkyl bromide is very high. Hence it is also a naming reaction. It is termed as Hunz-Dicker reaction. So mechanism I'm not giving, that is just written. But some people ask, sir, what about if I do not use Br2, rather I use I2, then what will happen? Silver salt of carboxylic acid can react with I2 as well. I'm not saying it is known reaction, but yes, product is changed. Then you get an ester. Yes, here also CO2, this is also decarboxylation, but here you have formed an ester rather than an alkyl halide. So alkyl iodide cannot be produced, only alkyl bromide can be produced using this halogen in CCl4 solvent. I hope everybody is clear. Now, sir, very, very important reaction. Sir, this was also given in amines chapter. That formation of aryl halide, very beautiful formation of aryl halide is through Sandmeyer's reaction. Now, what is this Sandmeyer reaction? Sir, first you need the reactant. Reactant is benzene diazonium chloride. What is diazonium group? Nitrogen group, nitrogen gas. How it is produced? Let's say I have aniline. I will react make this aniline react with nitrous acid. So nitrous acid is unstable. So we create nitrous acid in the runtime. How to prepare it? We use mixture of NaNO2 and HCl. They in runtime they produce nitrous acid, which is HNO2 that I've drawn. But you cannot use it directly because bottle of nitrous acid is not available. Why it is not available? Because nitrous acid is unstable. If I make nitrous acid, fill it in bottle and sell in the market, sir, once people will buy it, it is nothing. It will be deformed. It will be decomposed. So I have to create nitrous acid in the runtime. Okay, sir. So if you use NaNO2 and HCl, you have created nitrous acid in the runtime. As this nitrous acid reacts with aniline, with this benzene with NH2, you get benzene diazonium chloride. This, sir, but nitrogen gas, sir, it is most stable diatomic molecule, sir. How it is holding, sir? Beta, you can definitely see if this electron goes over here, this electron is recovered from here. So that means it is in resonance. So this has a partial double bond character, and that's why aryl diazonium salt exists. I am not saying it is stable, it exists. But yes, in order to stop this nitrogen gas, it can only stay when kinetic energy of the gas is minimized, and hence in order to minimize this, I keep a temperature of 0 to 5 degrees Celsius, that is ice cold condition. And only at ice cold condition, because kinetic energy of the gas is very much reduced, this benzene or aromatic diazonium salt exists. And this act as a very beautiful starting material. Why? Because we definitely know this nitrogen is willing to just leave in a jiffy. The moment it will leave, it will create a positivity. Although benzene is electron rich, but this will create a perfect plus. A perfect plus will allow all the minus, all the nucleophile to attack in this benzene ring. Because who is deciding the chemical kinetics of this reaction? This nitrogen gas. You may be strong, you may be electron deficient, you may be anything, but who is deciding the kinetics of this reaction? Nitrogen is going to remove as nitrogen gas, and therefore whoever you are definitely bound to get this positive charge, and plus a complete plus will allow all the minus to be substituted here, and hence you can form all the possible aryl aromatic compounds that you wish to produce. Hence it is the perfect starting material. Some people say that, sir, because temperature is small, so even you can form alkyl diazonium. No beta, because this R bond N is having no resonance stability, so even at 0 to 5 degrees Celsius, alkyl diazonium salt cannot be produced. So this is a specific reaction of aryl diazonium salts. Now, sir, you are saying everything will be produced, so let show us those reactions, sir. Giving you these reactions specifically for aryl halides. So with cuprous halide Cu2x2, you get aromatic halide. With Ki, you get iodobenzene. With fluoroboric acid, which is HbF4, first you form benzene diazonium fluoroborate. Now this is a salt which is stable till room temperature. A very important point. This is a salt. Technically, any diazonium compound is not stable. They only exist at 0 to 5 degrees Celsius. But this benzene diazonium fluoroborate is a beautiful salt which is stable till room temperature. Therefore, you have to heat it. Hence, once you heat it, fluorine is released, the BF3 is gone, nitrogen gas is gone, and whatever extra fluoride ion you have got is transformed into the ring, and you ultimately get fluorobenzene. If instead of cuprous halide, I use copper powder in HX, then also you get halobenzene. But yes, that then termed as Getterman reaction, because that is just the change of catalyst. But yes, because it has been patented, so you should know. If instead of, Neha is saying spamming, sir, spammers aa gaye. Beta, Neha, leave na. You are our superstar. So do you feel a superstar? Do you feel you will be giving your NEET examination and there will be no person around you who will be, I mean, if you are serious enough, he will be Beta, at this point of time now, we should be inert. The focus, your focus. Am I doing any questions over here that you have to practice? Am I solving any question where, sir, we are just revising the complete concept with all the details. So you just have to obviously keep on repeating with me, but you just need me in your screen. I guess, yes, whenever I'm asking something, you can obviously give, but yes, I understand that. So, chalo, no worries. Let's start. हाँ बेटा, please, guys, have this level of compassion. All the people who are active in the chat section, बेटा, please study, है ना? चलो. हाँ, ओके. शी सिंह सर, आप पढ़ाओ, आप कंटिन्यू रखो, हम लोग लगे हैं. चलो. अच्छा नहीं, मुस्कान इज ऑल्सो सेइंग सर, yep, you continue. चलो. सर कंटिन्यू. ओके. जियान इज ऑल्सो सेइंग, बट सर हम साथ साथ. हाँ, एग्जैक्टली exactly. नहीं नहीं मुस्कान, इफ यू आर राइटिंग, दैट इज वेरी गुड, but there are some people who can't write. So if you're writing, that's good. Because if you ask me, no, as a student, I could not listen and write at the same. I was a very slow writer. Still I am. So uh, there are some, and technically, I after class 12th, I mean, I was an MP board student, so no coaching also. I have after class 12th, I took a drop. Yes, in that drop year, I studied like anything. But yes, it was just 9-10 months of drop, and yes, I scored. My JE rank was 6,000. Although at my point of time there were only 5 IIT, so I didn't get an IIT. But yes, I definitely landed into an NIT, NIT Kurukshetra. But yes, beta. But still, I was good with studies, but my writing speed was horrible. Still horrible speed. So the point that I'm making is, if you are comfortable in writing, you should write. Else, read this. The notes you can directly get from where? PW NEET English WhatsApp channel. है ना? चलो, start. Let's continue, बेटा. Cool. थोड़ा हिंदी. नहीं नहीं, हिंदी तो नहीं बोल सकते बेटा. आती है, but I cannot, because read the name of the channel. You have to be compassionate enough, beta. There are students who are not comfortable, who are rather comfortable in the language of English. Chalo, moving forward. Now, sir, this we know, sir. Now, what else, sir? Beta, coming to the basic mechanism, SN2 and SN1. Sir, coming to the basic mechanism, SN2 and SN1. Sir, alkyl halides undergo substitution reaction. We all know that. How the substitution happens? Sir, if my alkyl halide is not bulky, then a nucleophile which is searching for the positivity at carbon will come and will attack. Everybody knows this. Sir, the OH has come and X has been removed as X minus. What is the mechanism, sir? Sir, backside attack take place. Why? Because if this carbon is not bulky, then I am interested in its delta positivity. So backside attack will take place, because this minus and minus of lone pair of electrons on halogen will repel. So obviously a backside attack will take place. A transition state will be formed where this is coming, halogen is leaving. Obviously this transition state will be trigonal bipyramidal, but I'm not saying carbon is making 5 bonds. This is a partial double bond, partial single bond between these two. This is coming, this is going, and obviously these 3 bonds are completely formed. But because this is backside attack, sir, so inversion of geometry will take place, which is known as Walden inversion. So this we know, this is a single step SN2 reaction. If we try to draw the chemical kinetics curve, then definitely, sir, this is potential energy of reactant, this is potential energy of product. So reaction reaches to a maxima, and then then the product is formed. Now, the most important point which many of the students fail to realize is, ultimately this is happening. Why? Sir, ultimately this is happening because of the fact that this minus is in love with this plus. Because this minus love plus, so electronic factor is the primary reason. Most of the student always think of the steric factor. Sir, steric factor will be applied when, because of electronic factor, I have approached. If the electronic factor was not there, then why the hell I will come to you? So point is, the main driving force between this nucleophilic substitution is this minus is attracted by this plus. So the first factor is electronic factor, and hence if you attach this carbon with an electron withdrawing group, that's why I've written PQR over here, not otherwise. I am not interested in its steric crowding. Rather, I am first interested if out of these PQR any group, if that group is electron withdrawing group, then actually that electron withdrawing group decreases the activation energy. Therefore, I do not have to reach to a highly activated transition state, and therefore that will be forming the product irrespective irrespective of my crowding, because I know 90% of the students answer SN reaction using steric crowding. Leave that steric crowding. Why the hell this minus is going to that plus? Because of the electronic factor. So please make sure, I do not care whether it is SN2 backside attack or anything else, SN1 or SNI. The primary factor is the electronic factor, which is increased once you have electron withdrawing group. I hope you will keep that in mind. Now, what about SN1? Yes, obviously, if it is electronically, it electronically, the minus has been allowed. But if I have a polar protic solvent, then sir, what is, first of all, sir, what is polar? Polar is obviously which is having dielectric constant plus minus. Protic, sir, which has ability to give H plus also. So if I have a polar protic solvent, who is that beautiful polar protic solvent? That polar protic solvent is water, sir, because the dielectric constant of water is highest among these like solvents. So if I have solvent like water, then such alkyl halide will do what? Because solvent is polar, so it will ionize the alkyl halide. Sir, halogen will leave and carbocation will be formed, and this carbocation will be trigonal planar. So now this plus is available for the attack from this side also and this side also. So if attack happens in this side, then orientation is this. If attack happens that side, then orientation is inverted. So that's why, let's say my alkyl halide was this. If it has gone, now I'm trigonal planar, so attack can happen this side also, so 50% retention. Attack can have from that side also, so 50% inversion. Everybody know, so that means 50% inversion, 50% retention. Technically, if halogen was here, so retention will not be 50%, it will be slightly less than 50%, because ultimately I'm leaving from here. But yes, generally we say that during SN1 there is 50% inversion and 50% retention, which makes the compound, if reactant is optically active, so this will make the compound optically inactive. But optical inactive due to formation of what? Due to formation of racemic mixture. I hope everybody is with me on this. So this is also done. Now, after this is done, sir, then this mean that in SN1 reaction, sir, first carbocation is formed, which is the rate determining step, the Stowe step, and in the second step, attack of this nucleophile can take place in any way. So 50% inversion, 50% retention, and I get my racemic mixture. But sir, give me the chemical kinetics regarding it. Beta, let's say this is the reactant, so product is formed. Sir, what product? Beta, because for every step you will having some activation energy. Now after this is the product of first step, as in carbocation. So this carbocation will also reach some activation energy and product will be formed. Sir, which activation energy is highest? This is highest. So this will give you the slowest step, and that's why we say first step is the slowest step, and ultimately I form my substituted product. This is the basic that you should know regarding SN1 and SN2. Now let us compare SN1 and SN2, because very important. Sir, what will be the relative rate of reaction? Sir, obviously, if no matter it is SN1 or SN2, iodides are more reactive, because sir, bond length is more. The easy X will go, the easy substitution will take place. Sir, what about the effect of structure? Sir, if I'm talking of SN1, then 3 degrees most reactive, methyl is least reactive, because carbocation is formed, so that carbocation is very stable. What about SN2? Obviously the opposite, sir. Methyl will be preferred, and 3 degree will never do this because that is crowded. What about effect of solvent, sir? You have already told, sir, in SN1, plus minus is formed in the first step, which is the slowest step. Hence, polar protic solvent will increase rate of reaction. What about SN2? Sir, I do not want plus minus. That means I do not want polar protic solvent. Rather, polarity will do. I do not want plus. I do not want H plus. So I can use a polar solvent because ultimately, even I want to form that trigonal bipyramidal transition state where I was having OH minus attacking and nucleophile minus going. So ultimately, I need polarity so that those ions can exist. But yes, I do not want H plus, or else H plus will surround and will try to ionize me. It will try to bring ionization. So I will require polar but aprotic solvent. Very famous examples are acetone, DMSO, and DMF. Dimethyl formamide and dimethyl sulfo oxides. Now, so I mean, just you should know these organic solvent will favor SN2. I hope everybody's good. Now, last thing is, sir, stereochemistry. That also you have told, sir, in SN1, if reactant is optically active, then product will be optically inactive, but inactive due to formation of racemic mixture. Sir, in SN2, if reactant is optically active and dextrorotatory, then product will be levorotatory because inversion take place. Walden inversion, the technical name we give during SN2 reaction. I hope everybody is clear with that also. Moving forward. Very important reaction. Very important practice question, and we are not going to we are just going to analyze this. Okay, let's do it. Sir, you have to assign order of reaction for SN1 also and SN2 also. Sir, this is easy, sir. This is methyl 1 degree, sir. This is no degree, this is methyl. This is 1 degree, this is 2 degree, and this is 3 degree. Then definitely I know with according to SN1, D will be most reactive, and according to SN2, A will be most reactive. Sir, what is this? This is very easy. Why you are asking, saying very good? Just look at the other question, and this is actually JEE advanced question. But yes, giving you this logic simply. How? Sir, this is my CH2Cl as an alkyl halide. I am not even interested in its degree. This carbon is connected with a carbonyl group. Now remember, this is electron withdrawing group. Do not think of steric factor, sir. Electronic factor will decide. So this will have SN reaction. I'm not saying 1 2. It will have SN reaction with fastest rate. Why? Because electron withdrawing group will increase the positivity, sir. Leave about steric hindrance or anything else. Electronic factor is most dominant. Sir, this is methyl. Sir, no, I mean obviously this will be best. Sir, this is aryl halide, sir. This will not undergo. We know, sir, it is having partial double bond character. So this guy will be least, and in fact, it will not be counted. Huh. Sir, this CH2, this is alkyl chloride, sir. This is not aryl because benzene is not connected. And in fact, benzene will act as a minus I group. Yes. Carbonyl is a strong electron withdrawing group, but benzene is also a minus I group. So this will be most reactive towards any type of SN reaction. So first most reactive will be A. Next most reactive will be Delhi, and in fact least will be Bombay, although this is least hindered. But I do not even care about hindrance. Why? Because electronic factor dominates. I hope everybody get that. Now, sir, coming to this question, so I hope now you get this point that whether I talk of SN1 or SN2, it doesn't even matter, sir. So this guy will not even react, so I will not even write it. Yes, this is having minus I of this, so delta positivity is increased. So this is obviously this is also minus I, so delta positivity, but here this minus I is because of the system of double bonds of benzene. This is just one double bond, and here, sir, there is no double bond, so there is no minus I group. So which will be most reactive, sir? This C, after that this B, at least some minus I, and least will be A. So technically you should answer the reactivity of SN reactions using electronic factor. Using electronic factor. I hope everybody is good. I hope everybody is good. Chalo. moving forward. Now, a very simple yet technical question on directly this basis. What is this, sir? Let's say if I have uh, this is what CF, huh? This is not CF beta. This is, I guess, hmm, there is no CF. So let us make this question like this. I have this compound where this is a carbon. So this will be dash and this will be wedge. And you have to predict the product. Obviously, sir, DMF is dimethyl formamide. Sir, this is a solvent for SN2. So that means that SN2 will take place. Sir, who is my nucleophile? You just have to identify this sulfur derivative. Technically, you have phenoxide. Here, you do not have phenoxide. You have sulfur derivative of that phenoxide ion. So this will rather act as a nucleophile. And once this nucleophile will attack, we can definitely assume and predict this, that this will be having a SN2 mechanism. Hence, if this bromine is in a wedge, it shall reach to a dash. It shall reach to a dash. So obviously I have this product for you. So this has reached to a dash, and uh, here this was wedge, so now this is dash, which is clearly showing inversion of geometry. So actually this was a J mains question only, and there were options, so I've just given you one of that option. So I hope you understand how to predict this SN2 optical inversion, which is Walden inversion rather. I hope everybody is clear. Moving forward now, sir, very important list from NCERT, because sir, what are the nucleophiles? These nucleophiles are very famous, and this famous NCERT photo will help you and make one question of you in your exam. How, sir? Sir, we know alkyl halide will be attacked by nucleophile and RNU will be my product. Now, what are the possible nucleophiles? If you have alcoholic NaOH or KOH, OH minus will be my nucleophile. Sir, water will give water only as nucleophile, although this is a neutral nucleophile, but once this oxygen lone pair will attack, hydrogen will be taken. So ultimately, with both, you have alcohol as your class of product. Now, if I have sodium alkoxide, the nucleophile is RO, with RO minus as an alkoxide. So product will be ether. With NaI, I will have Ri. With ammonia, I will have 1-digramine, although ammonia is also a neutral nucleophile. Lone pair will attack, and then H will be removed as H plus. So ultimately, I get 1-digramine. Sir, with 1 degree amine, you form 2 degree. With 2 degree, you form 3 degree. Sir, with KCN, sir, KCN and AGCN is a beautiful case of ambident nucleophile. What is this ambident nucleophile? Sir, KCN is an ionic compound, will completely dissociate as K plus and CN minus. Sir, Cn minus will have minus as a negative charge on carbon. So who will act as a nucleophile? Sir, this C minus. So who will attach to R? Sir, C minus. So what will be formed? Sir, RCN, which is nitrile or simply cyanide. If I have AgCN, then sir, AgCN is covalent salt, sir. This will not form, this will not break as plus minus. So carbon is not even having electrons, sir. So how will it give electron? So the only possibility of nucleophile is lone pair on nitrogen. So who will give electrons? A lone pair of nitrogen. So who will attach? So lone pair of nitrogen. So R will be bonded with N, hence it will be isocyanide, a beautiful case of ambident nucleophiles. Sir, the same will be happening once we use KNO2 or AgNO2. Sir, in KNO2, nucleophile will be NO2 minus. In AgNO2, nucleophile will be, sir, nitrogen also have lone pair, oxygen also, but now nitrogen will give. Why? Because oxygen is electronegative. Why oxygen was giving in that case? Because it was having excess of electron. It was a negatively charged species. If both are neutral, so nitrogen will give. So here, oxygen will negate. So product will be alkyl nitrile. Sorry, alkyl nitrite Te. Alkyl nitrite. When nitrogen will give, it will be nitroalkane. Nitroalkane is common, but when O gives, it is nitrite. Sir, C triple bonded N is nitrile with a LE. This is nitrite with a TE. I hope, beta, very important points. Very important points. Guys, chalo, next. Sir, yes. If you have silver salt of carboxylate, sir, salt will give RCOO minus, sir. So this minus will be attached and you will be forming your corresponding ester. Sir, lithium aluminum hydride will give H minus, sir. So you will be forming corresponding RH as an alkane. Sir, if I have R minus, because any metal will make carbon electronegative, so it will give R minus as an alkyl group as a nucleophile. So that will be attached to form an higher alkane. Very famous points. Now, sir, if we definitely know sodium alkynide, so this R C triple bond C minus, it will form higher alkyne. NaSH will give, just like NaOH, it will give SH minus, sir. S minus will also give electron and will form not alcohol, sir, but it will be termed as thiol. I hope everybody's clear. Now these are some basic reactions. These are some basic and famous reactions which will help you to understand and finish the chapter of alkyl and aryl halides. Sir, why you have finished it completely? Because beta, most of the reactions we have read in the case of alkyl and aryl halides. Now quickly moving to the chapter of so I hope everybody is good, guys. Guys, chalo, perfect. And superstar is always present. Great beta, pakka. Okay, okay, chalo, perfect beta, great. Your DP, okay. Next karo sir, chalo, perfect. Okay, the Lulu is also here. Chalo beta, done. Chalo beta. So we have finished what, sir? Sir, first we have finished. Now we are starting with alcohol, phenol, and ether. So let us quickly. Have a water break. I am also having a water break and a coffee break. By the time, beta, you can definitely write this preparation of alcohols if. Okay, Tushar. By the time I'm just reading few comments. Yes, sir. Confidence has grown. Thank you, good sunshine. Beta, if you just read, sun is definitely going to shine. The sessions which we have like this, beta, obviously, once you're trying to revise something, you have to push yourself. So with this, we are doing nothing, but rather we are pushing ourselves. Chalo, chalo. Quick. Let's start alcohols. Let's start the chapter of alcohols. So now, actually, most of the reactions we have done only, sir. But still, let us see how. So the very first and the very main type of reaction we should know from the chapter of alcohols is that, sir, the preparation of alcohols. So most of the preparations we have seen. But yes, that from alkenes, if you want to prepare alcohol, sir, then definitely hydration of alkene we know, sir. Sir, first H plus will attack, then carbocation will be formed, then rearrangement, and then OH minus one will attack, and therefore from alkene I can form alcohol. So what is the common sense that we are generating? that one of the method is acid catalyzed hydration. So first, who will attack, sir? H plus, carbocation will be formed, sir. We have seen in the reactions of alkene Marconi-Kov addition, and definitely this is Marconi-Kov addition because carbocation is formed, sir. So rearrangement can take place, and this will be non-stereo specific in nature or regio specific. Obviously, it is not having any problem. You just see that alkene attack H plus, form carbocation, get rearrangement, give your product. But I can form I can form alcohol with alkene with another reactants also, and beta, this is there in NCERT also and very famous. And this is the only reaction which is not discussed in in previous discussion of ours. First one is mercuration and demercuration. Now, how does this mercuration and demercuration works? The mercuration, and during mercuration and demercuration, what we do is, sir, first we take mercuric diacetate. Sir, we definitely know this oxygen being electronegative can be removed, giving positivity in this mercury +1 charge. Sir, seeing this plus, sir, the lone pair of alkene will attack this plus, and sir, again the cyclic structure is formed. Now, why I'm saying the cyclic structure, beta? Because here again, just like the cyclic brominium cation we have formed, I was trying to do Marconi-Kov addition only, but I needed the carbocation where I will not do any rearrangement. And here also, why this mechanism is predicted, because in such cases you directly have Marconi-Kov addition, because there is no rearrangement that has been seen in nature, and hence we have designed such a reaction where we form a cyclic cation, so that now whatever electron rich species going to attack, it will attack to that carbon which is having delta positivity better. Who will have better delta positivity? This will be 3 degree, this will be 2 degree. So obviously that carbon will have better delta positivity. Sir, why you are thinking of delta positivity? Because if you form a stable carbocation, then the problem of rearrangement will start. That's why we have given a mechanism prediction that here this cyclic cation is formed, not complete carbocation, but still the negative part of attacking species will go to that carbon which is having more stable partial carbocation, and hence this will be formed. And after mercuration, I'll do demercuration. Demercuration is done using a reducing agent like NaBH4, and then this is removed and hydrogen is attached. So sir, addition of hydrogen is reduction. So this reduced product is nothing but Marconi-Kov addition of water also only. So because H added here, OH added here, sir, OH as a negative part of attacking species has added to that double bonded carbon which has lesser number of hydrogen atom. So that means this is also Marconi-Kov addition. But the only problem is here in this we have no rearrangement. Here in this we have no rearrangement, point number one. Now, next is I have got flies over here. Now, next is hydroboration oxidation. Next is hydroboration oxidation. So the reagent is B2H6 in presence of THF followed by H2O2 in basic medium. Now this have anti-Marconi-Kov addition of water. Here also no rearrangement take place because here also no carbocation is formed. So what is the basic mechanism, sir? Beta, this is my alkene. This is my BH3. This boron having empty d orbital makes it a Lewis acid. These lone pair obviously make it electron rich. So plus minus attract each other. Sir, I cannot see any plus. Beta boron has having empty p orbitals. So electron deficient species is like a plus. Electron rich pi cloud is like a minus. This plus minus will attract each other. The moment it attracts, sir, boron is bulky, sir. It will attach to which carbon? It will attach to that carbon which is least hindered. So which carbon is least hindered in this case? So this one is attached with methyl. This is least hindered, sir. So this bulky boron will be attached to this carbon. The moment it has attached to this carbon, the other one will get the hydrogen of this BH3. So this side will get BH2. that side will get hydrogen. Why? Because boron will be attracted and fixed to that carbon which is least hindered. I hope point is clear. Sir, if it has happened once, then again boron is electron deficient, sir, Lewis acid. So again it will attract the pi cloud, but in the same fashion boron will be attached to least hindered and it will lose hydrogen and give to other one. So that means it can happen 3 times. After H2O2 in basic medium, sir, this bond will break. Boron will also get OH. They will also get OH. So ultimately H added here, OH added here. So what is produced? Sir, ultimately you have produced alcohol by anti-Markovnikov addition of water in an alkene. So these 3 reactions, hydration, oxymercuration, demercuration, and hydroboration oxidation of alkenes to form alcohol, forms a very classic level of reactions. Beta, you will get number of reactions on this basis. I hope everybody is clear. Now, some more preparation of alcohol, sir. Sir, aldehydes and ketones, that those are carbonyl compound. If you try to reduce these carbonyl compounds, then sir, we have already seen oxidation in the chapter of alkanes. So if you reduce aldehyde and ketone, add hydrogen, you will get alcohol. Sir, with aldehyde you get 1 degree alcohol, with ketone you will get 2 degree alcohol. What are these reducing agents, sir? Catalytic hydrogenation. LiLH4 can do this anytime, and yes, very famous reducing agent is NaBH4. Beta, NaBH4 acts as a reducing agent only for aldehydes and ketones. Very famous. Please please keep this thing in your head. Now, obviously you can reduce carboxylic acid also. You can use the expensive reagent, but it will reduce alcohol, it will reduce acid to 1 degree alcohol. Sir, alcohol is not that expensive. This is a very expensive reducing agent, so rather economically we do not do that. So what do we do? Sir, acid and alcohol can form ester easily. So ester is formed. Now ester is very easy to reduce. Acid is difficult to reduce. Ester is very easy to reduce. How? Catalytic hydrogenation. So you will form alcohol, this and alcohol that. So both of them will form alcohol. Yes, one of the alcohol you have even used, so it can even be reused. So practically, industrially, it becomes a very feasible method. I hope everybody is good. Now, next is Grignard reagent. Again, very famous and very common. If you have any carbonyl compound, sir, carbonyl compound has positivity, so this is nothing but nucleophilic addition, sir. Nucleophilic addition, this is nucleophile adding to this guy. So this is just like alkene having electrophilic addition, carbonyl compounds have nucleophilic addition. So this nucleophilic addition will make minus of oxygen go there. Post hydrolysis, you form your alcohol. So this is next method of preparation of alcohol from carbonyl compound using Grignard reagent. Very important, beta. This you have already seen preparation of phenol, which was Dow's process using aryl halide. Sir, if I have benzene, then I use benzene sulfonic acid. So then I use oleum, it will give me benzene sulfonic acid. Sir, this is a very because carbon bond sulfur has very high bond length, so bond can easily break. If bond easily break, that means, sir, even if you use a base, this bond can easily be broken. And if it is broken, sir, that will be removed, and here I'll be forming phenol. But sir, this phenol in presence of a base can only be existing as a salt. So you get sodium phenoxide. So you have to do acidification in order to get your corresponding phenol. Sir, that means with this you have reached reactions of phenol. Definitely yes, beta. Now, sir, diazonium also. Sir, benzene diazonium salt, you have already told us, sir. So if you just add water, the lone pair of oxygen will go and you get your corresponding phenol with the release of nitrogen gas. These are very predictable reactions, sir. Very, very important reaction, beta, with cumene, which is isopropyl benzene. Let us understand this through mechanism also. First of all, what we do, oxidation. Sir, this benzylic hydrogen gets oxidized and I get O bond O over here. Okay, sir. After that, beta, after that, what we do is we do acidification. Sir, acidification, first this oxygen will get protonated, so this is OH2 plus. Sir, now oxygen has positive charge, so it will definitely try to go, but who will give electron? The electron is offered by the benzene ring to that oxygen, and that oxygen gives away its electron, the peroxided oxygen, this O bond O. But why this oxygen is giving away its electron? Because it is offered its electron with the benzene ring. That tells me if benzene is substituted with a plus R group, if benzene is substituted with the electron donating group, sir, then this step will be fast. So this mechanism will help you understand that what type of benzene will give the electron donating nature of benzene will be having more affinity towards this cumene getting into a phenol. The more you have electron donating group here, the faster this can happen. So some good questions can be solved with this. Now, so that means this oxygen will be getting phenyl. Yes, beta, it has got phenyl. After that, sir, this carbon has got plus positive charge. So now water will attack at this carbon. It will take electron from hydrogen. So that means this carbon has got OH. And after this, sir, this is quite clear. This is now like an ether, so this oxygen will be protonated. So this C bond O can't be broken because this is aromatic, this is resonance stabilized. So rather this will be moved. This side is your phenol and this size is your acetone. Now, a very beautiful mechanism, but you should not learn the complete mechanism, just learn the idea. What is that idea? Idea is definitely cumene reacts with oxygen followed by acidification, forms phenol and acetone. I hope everybody is clear. Now, sir, what about chemical reactions of alcohol? Beta, alcohol can react as nucleophile also. It can it can behave as electrophile also. Sir, when and how it can act as a nucleophile, sir? Beta, the lone pair of electrons present in oxygen will be attracted by the positivity, sir, because minus and plus will attack. But ultimately, this alcohol is going where? Sir, this alcohol is going in search of plus. Plus is nucleophile. So alcohol is acting as a nucleophile. Once alcohol act as a nucleophile, ultimately this oxygen will get a positive charge. The moment this oxygen get a positive charge, it will snatch electron of hydrogen, and this deprotonation will result into the formation of some product. This product can be anything. You just look at the mechanism. So ultimately, what bond of alcohol is broken? Sir, C bond H. Sorry, O bond H. That means during this reaction, alcohol is trying to behave as an acid. So when alcohol behave as an acid, when it behaves as a nucleophile. Other way around. Sir, but in alcohol only oxygen lone pair can attack. Yes, beta. But if they are attacking some H plus, then sir, it will become protonated. So protonated alcohol, sir, water will be released. Now it has got positivity. And once this carbon has got positivity, it will be approached by some minus. So you tell me this plus is attracting what? This plus as in protonated alcohol is attracting minus. So protonated alcohol is acting as a minus loving species. So protonated alcohol acts as a minus loving as an electrophile. So whenever protonated alcohol attacks or reacts, it reacts as an electrophile, and which bond breaks? Sir, in this case, C bond O breaks. So very important point, beta. When C bond O bond of alcohol is broken, actually protonated alcohol has reacted as an electrophile. When O bond H of alcohol has broken, basic alcohol, I mean traditional alcohol, has behaved as a nucleophile. A very important NCERT point, beta. I hope you remember this. Now, some basic reactions. So we have already seen it can act as acid. O bond H can break. So it can react with metal and form salt and hydrogen gas. Very easy. Sir, because it can act as an acid. So what increases acidic nature? Beta, electron withdrawing group increases acidic nature. Electron donating group decreases acidic nature. Hence, 1 degree alcohol will be, in fact, methyl alcohol will be most acidic. 3 degree alcohol will be least acidic. If you compare acidic nature of aliphatic alcohol with water, then definitely, sir, OH minus If compared with RO minus, then common sense is telling me, sir, this is a strong base. If it is a strong base, that means this is a strong base. That means backward reaction will take place. That means water is a strong acid. Water is a strong acid because this is a weak base. I hope you remember that Bronsted acid, Bronsted and Lowry conjugate acid base theory. If this is a strong base, that means this will give electron. If this is giving electron, equilibrium will be shifted in backward direction. That means alcohol is a weaker acid than water. And how you can easily predict that? Using the inductive effect on OH minus and RO minus. I hope everybody is clear. Now, sir, what is the point? With this, I am trying to make you realize that all aliphatic alcohol are even weaker acids than water. Water is a stronger acid than all aliphatic alcohol except one, methyl alcohol. Now, why methyl alcohol is a stronger acid? No logic, just the experimental value of Ka. If an acid is strong, it will have greater value of dissociation constant. So just because of the higher value of dissociation constant of methyl alcohol, only methyl alcohol without any justification, just on the basis of the data, although not very strongly acidic, slightly more acidic than water. I hope everybody get it. Technically, all aliphatic alcohol are weak acid than water, and if you compare this with phenol, then sir, after giving H plus, phenoxide ion is resonance stabilized. That means aromatic alcohol are stronger acid than water. That's why phenol reacts with base and give neutralization. Aliphatic alcohol can't do so. I hope everybody get it. Now, sir, you have already told us alcohol can act. Yes, in comparison to carboxylic acid, it cannot. But technically, if alcohol and carboxylic acid or its derivatives react, then alcohol releases H and carboxylic acid or its derivative releases OH or the substituted part of OH, and they form corresponding ester. This process is termed as esterification. Now, sir, a very famous example of esterification gives, sir, beta, if you have salicylic acid. What is salicylic acid? 2-hydroxybenzoic acid. Sir, ultimately I have alcohol. If it reacts with acid anhydride, that means I have acid derivative. So alcohol will give H, carboxylic acid will give OH or substituted part. Sir, then CH3COOH gone. That means with this O, I'm having this CH3CO. So, sir, what is produced? Beta, this way you have produced acetyl salicylic acid, which is simply termed as aspirin. Sir, this is also an ester. But this ester is a powerful anti-pyretic also and analgesic also. What is an anti-pyretic? Which cures your fever. What is an analgesic? Which is a painkiller. That's why this aspirin is very important and hence given in NCERT. Very important point. I hope everybody is with me on this. Now, sir, mechanism of esterification. This mechanism will only help you to have an idea. What idea, sir? First, beta, this lone pair of oxygen attacks to this H plus and it gets protonated. Who is getting protonated? This carbonyl carbon. The moment it is getting protonated, now it is attacked by alcohol lone pair, because ultimately who attacks in alcohols are the lone pair of oxygen. Because it was neutral, so neutral cannot react with each other. That's why I need some initial protonation. So this lone pair of electron on oxygen, after getting protonated, they will create complete positive in this carbonyl carbon. And now this plus will invite the lone pair of electron on oxygen of alcohol to attack. Once that attack has taken place, I hope you can see this. Now this is quite easy. Sir, oxygen will take electron of hydrogen and that hydrogen will be offered electron by the OH of carboxylic acid. This will be protonated, sir, and soon this will be, because this is now plus, so this will be removed and you get your protonated ester. The moment you have your protonated ester, deprotonation will take place and you will form your corresponding ester. Now what it is telling you, Sir, it is telling me that if this carbon, carbonyl carbon, is having more positivity, alcohol will be attacking more. So you tell me, formic acid or acetic acid, who will undergo esterification fast? Just this common sense. Sir, formic acid will have only H. Sir, acetic acid will have CH3. Which carbon can have this positivity easily? Sir, hydrogen. The moment you add that alkyl group, it will try to give electron, and once it is trying to give electron, the positivity of this carbonyl carbon is decreasing. That means, sir, it is just like nucleophilic. This is an electron rich species which is loving this positivity of carbon. That means that this is another example of nucleophilic addition on carbonyl carbon. You have that nucleophilic addition reactions in the complete chapter of aldehyde ketone and carboxylic acid. The same thing is applied, although this is not aldehyde ketone, but still that carbonyl group is deciding. As we say that nucleophilic addition reaction is given by whom? Sir, aldehyde give nucleophilic addition reaction to a fastest extent than ketones. Why? Because of electronic effect also and steric effect also. The same reason you can apply for this esterification also. I hope you are getting the idea. Guys, perfect. Neha is still saying perfectly. You are superstar beta. Come on. Just approaching the end of alcohols also. Now, sir, oxidation of alcohols. Sir, this we have already seen, sir. The list in alkanes chapter you show. So, sir, 1 degree alcohol will form acid and aldehyde. With strong oxidizing agent, you can get acid because complete oxidation. With mild, you will only do it once. So, only one H will be transformed to OH. So, it will form aldehyde. Sir, with 2 degree, you use any agent, sir, because it has only one H. Because strong or mild, whatever oxidizing agent you are, you can only replace C bond H with OH. Sir, 2 degree alcohol has 2 C bond C. It has only one H. So either you use mild or strong, you are going to end up at ketone. What are the list of these oxidizing agents? Some mild oxidizing agent can be PCC, which is pyridinium chlorochromate. NCERT gives the complete detail. This is mixture of CrO3, pyridine and HCl. Sir, you can also use CrO3 in anhydrous condition, as in you should not have any water or acid. So that will also act as a mild oxidizing agent. KMNO4, K2, Cr27, everybody know. Just know one more because it is an NCERT fact regarding Jones reagent, because that is also CrO3 but not in anhydrous medium. In acidic medium, if you take CrO3, then that CrO3 becomes a strong oxidizing agent. A very important point. Now, okay, sir, alcohol can also be oxidized, but yes, not by adding oxygen, by removing hydrogen. Sir, hydrogen can be removed by heated copper at 300 degrees Celsius. Yes, it can also be done using silver, but copper is NCERT tells this. So with 1 degree alcohol, you form aldehyde. With 2 degree, you form ketone. So technically, 3 degree alcohol is inert with oxidizing agent. With heated copper also, 3 degree alcohol are not going to get oxidized, but yes, they are not inert. With strong oxidizing agent or any oxidizing agent, 3 degree alcohol do not react, but with heated copper they form alkene, because instead of dehydration, as in here it is removing hydrogen, here it is removing hydrogen, here it is removing H and OH, so water. So ultimately it is not no reaction, but rather it is formation of alkene. I hope everybody get it. Chalo, perfect. Now, because again, a very extra point, you can also skip it, but yes, rather because that's a RE-NEET, so you should also, hardly it will matter. So 2 degree alcohol can also be oxidized to ketone. How? Using acetone. You can use any 2 degree alcohol and form any ketone, but using acetone and aluminium tertiary butoxide. This is called open-air oxidation. A very important point, and this open-air oxidation beta, it do not do anything to olefins, as in it keeps the double bonded or triple bonded carbon unchanged. It just oxidizes the 2 degree alcohol, and precisely 2 degree alcohol. I hope everybody is with me. Now, obviously, first alcohol gives electron to aluminium. This one tertiary butoxide is gone. that alcohol came, ultimately this alcohol has lost this hydrogen, but if this carbon also needs to lose this hydrogen, then only they'll form ketone. So after first step, one hydrogen gone, whatever acetone you have used, now lone pair of electron or oxygen will attack aluminium, will give electron, and then aluminium will furnish the electron to carbon, and therefore this hydrogen will also be removed in form of H minus. I hope you can see that. So ultimately I have got my ketone, and ultimately this is my byproduct. So ultimately whatever 2-degree alcohol you have used has transformed itself into 2-degree alcohol has transformed itself into ketone. Very important point. Next. Sir, reactions of alcohol you have already told us, sir. What is it? Beta phenol, very powerful plus R group. So with dilute HNO3, ortho para. Sir, but ortho is good enough because of intramolecular hydrogen bonding. So we don't say only para, we say ortho para. With concentrated HNO3, you form picric acid. With oleum, you get ortho and para substituted sulfonic acid beta. Why? Why? Because excessive can't take place because sulfur is very bulky. So it takes place with respect to oxygen at position 2 and position 4 only. Now once you treat this with concentrated nitric acid, you again get picric acid, and technically forming picric acid this way is more and more productive because percentage yield is more. So what is the reason behind it? Because beta, this is a very powerful leaving group. So leaving group leaves and allows the nitration to happen with larger rate of reaction. Although this is a very precise detail, you can also skip it, but still, if anybody of you is interested enough, then this is a very famous industrial detail. Guys, chalo. Now, sir, what about other reactions? Beta phenol, because powerful activating group. So bromination can also take place, ortho para, but here ortho will have no intramolecular H bonding, so it will be para will be the major product. Sir, if I use Br2 in water, then ultimately Br plus is going to attack because benzene ring is electron rich, but heavy bromination will take place, as in bromine at all 2, 4, 6 position, and actually this tri-bromo derivative is precipitated out, and you can see it also. So it is also sometimes behaving as a test. So this forms a white PPT. And definitely if you do chlorination with any Lewis acid, so sir, you know alcohol is having lone pair, so it is a base. So this is a Lewis acid, so they will react. So obviously all the reactions of aromatic compounds which are using this Lewis acid, like Friedel-Crafts alkylation, acylation, obviously alcohol will not respond to that because I have already written as Cl2 act as oxidant and converts into benzoquinone. Although this is writing some other logic, it is saying that Cl2 for phenol act as an oxidant and converts it into benzophenone, as in this gets oxidized and convert to corresponding ketone of phenol, which is benzoquinone. This is again an industrial fact that Cl2 per se for phenol can act as a oxidizing agent. Else you can also compare that thing, that lone pair of electron on oxygen can interact with anhydrous AlCl3 or the Lewis acid present. So that's why even Friedel-Crafts reaction we have not seen. Now important reactions. What important reaction? Kolbe reaction. Very easy, but yes, rather very important. Sir, phenol once reacted with base will form sodium phenoxide. Sir, sodium phenoxide once treated with CO2, sir, this carbon is positive, sir, this is minus. This carbon is positivity and that is minus. But sir, instead of oxygen minus, sir, the minus will go in benzene ring also because it will be having minus at ortho and para position. So don't you feel at ortho and para position, carbon will give electron or oxygen will give electron? Obviously beta, carbon will give electron. Sir, carbon can give electron from ortho position also and para position also, but ultimately I am proceeding via ortho position. Why? Because after hydrolysis, the product that you will be forming will be having intramolecular hydrogen bonding. That's why I am preferably making ortho substituted product, and this product is called salicylic acid. You can simply write this this reaction like this. Although I have this mechanism also for you, that at this ortho position, attack to this carbon. The moment this carbon has attached, now deprotonation will take place and you have formed your phenol, and this phenol after protonation will form salicylic acid. Now, very precise detail, but yes, if somebody grabs your neck and asks you, I can never produce para isomer, you can. If you increase temperature, then the crowding will start hampering, and then para, the substituted product, becomes major product. So temperature has to be increased above 430 Kelvin. A very precise detail, you can skip this, but at least you should know this much. Now, sir, if CCl4 reacts with KOH, then ultimately again you are going to produce CO2. So again, even in a reaction, it is showing that you have phenol with CCl4 and KOH, then you treat this reaction also as NaOH and CO2. That is, you treat again as coal-base reaction. I hope everybody is clear. Moving to Remerteman reaction, where again you have basic medium, but now you do not have CO2, you have chloroform. This chloroform with base forms dichlorocarbene. Although this dichlorocarbene has this lone pair, but ultimately if you count number of electrons, this carbon is electron deficient. Sir, if I'm electron deficient, I need electrons, so I'll be electrophile. So who will give me electrons? Sir, benzene ring. Why? Because benzene is substituted with double bonded O. How this double bonded O forms, sir? Because phenol in basic medium will again form phenoxide. The minus will again go to ortho and para position. Then, sir, again you are interested in ortho. Why? I will tell you with the product. So ortho position, attack take place. After deprotonation, this I got post. Okay, after deprotonation, this I got medium is basic. So these two chlorine will be replaced by OH. One carbon having two OH will form aldehyde. After protonation, this will be having H plus. So ultimately what product we have formed? Sir, ortho substituted alcohol and aldehyde. So they will also have intramolecular hydrogen bonding. So because of intramolecular hydrogen bonding, again, what product I have preferably formed? Ortho substituted. This ortho substituted product is called salicylaldehyde. I hope everybody is clear. I hope everybody is clear. Perfect. Now, sir, this reaction we have already seen in the preparation of benzene. Phenol reaction with zinc dust forms benzene. Now, the oxidation with Cl2 that I have written over there, let us look at that oxidation also. That technically phenol can be oxidized, but yes, very specific reagent. It is chromic acid, which is mixture of Na2Cr2O7 and H2SO4. It forms benzoquinone. This is benzoquinone, and yes, benzoquinone can also be seen because this is also a brilliant red color compound. But why it shows that brilliant red color? Because this benzoquinone happens to be hydrogen bonded with phenol. And because of this hydrogen bonded structure, the complete array, the complete mixture appears very dark colored compound, and that dark color is technically brilliant red color, and that's why this also sometimes behave as a test for phenol. Now, because I was talking of test, so let us explore few steps. The first test being Lucas test for alcohols. Sir, we have already done that. 3-degree alcohol divide turbidity immediately. Then we have Victor Mayer test, which forms red color with 1-degree alcohol, blue color with 2-degree alcohol, and the 3-degree alcohol remains colorless. What is Victor Mayer test? First we react alcohol with red phosphorus I2, then with silver nitrite, then with nitrous acid, and after that we add a base. If I get a red color, that means I'm a 1-degree alcohol. If I get a blue color, that means I'm a 2-degree alcohol. And if I'm colorless, if after adding base the solution is colorless, then that means it is a 3-degree alcohol. Moving forward, effervescence tests are obviously effervescence will be created once you have carboxylic acid, because carboxylic acid is a stronger acid than carbonic acid also. So it will release CO2, and whenever CO2 you get that brisk effervescence. Although phenol is a stronger acid than base, but it is not a stronger acid than carbonic acid H2CO3. So with phenol you do not get any effervescence. That means that's a distinction test between carboxylic acid and phenols. Neutral FeCl3 test, very beautiful. It is only given by phenol. Phenol gives you what? Phenol gives you a violet color complex. Phenol gives you a violet color complex. Now, sir, for phenol, we have also known one test which is Br2 in water, because that will be doing heavy bromination at orthopara position and a white PPT will be formed. So that reaction we should also remember. Last one is the dye test. Obviously, we see this test in the coupling reaction of the chapter of amines also. So again, an NCERT reaction. So we have a diazonium salt. If I have phenol, then the para substitution, because this phenol is also electron rich in basic medium, it will be phenoxide. So orthopara, here there is no possibility of hydrogen bonding. So here para will only attack and you will get a coupled product. So with phenol, what color dye you get a orange colored dye. So I hope everybody get this much. Chalo beta. With this, I guess, yes. So I have some more reactions with me, but yes, I guess let's call it a day, because this is, I guess, 1:15 and we have covered most of the reactions. Sir, what about the other reactions? Sir, you will not teach them, you will not make us revise them. Definitely beta, we can and we will revise them, but how? Practically, the initial chapter of hydrocarbons is actually important for us to have an idea. After that hydrocarbon discussion of basic level of understanding is done, now you can clearly understand and read using questions only. So yes, I will be definitely coming again, but yes, with the relevant question practice of organic chemistry also and complete chemistry. So let's call it a day. I hope you have enjoyed. If any one of you wants to actually practice this to a more extent, I will be transferring all these lecture notes to my team and they will be uploading it just in the morning in PW NEET English WhatsApp channel. So just go over there, download these notes, and definitely you can obviously read these notes which I have prepared with my hands. So this is it. Let us call it a day then, guys. Ha beta. Neha, our superstar, is always there. Okay. Pen. Okay. Okay. Pen. Okay. Chalo. Chalo beta. So let's call it a day, and please make sure that whatever days you are left with beta, make it, utilize them to your best of your efficiency, all the very best, because I can still see these 60 students still there with me. So thank you beta, but please keep on revising and practicing. So we will meet soon and with the next class. So bye bye, take care.